Hello. When the session will start?
I have no idea. However, some is waiting for 10 to 15 minutes for others to join. This session will be taken by millions of them of instructors.
Okay, good evening, everyone.
Good evening, sir.
Good evening.
Let's start the session. So today's session is mostly we are going to solve some problems from mock test. So it will be better that I won't be able. I'm not going to solve like all the 16 questions because anyways it's not that useful, I guess. You guys have like very less time between the exam and now. So can you just tell me like whichever the question numbers, like which
So the parking
you
question,
guys,
can you solve that first?
which one?
The parking question.
Parking question, which parking question? It's mock test, right?
Yeah, it's
Mock
from the
Yes,
mock
sir.
test.
Okay, 10 cars. The John parked car is this one.
Yeah, yeah.
Okay. No, tell me the question numbers so that I'll go one by one. So, okay.
Question number 3 also going to.
Three.
Question number 1.
One. Okay. One. Then question
3,
number
sir.
3. Okay. Then
8 and
fourth.
9.
Four.
Question
I
number
think.
8, sir. Question number
Not.
8, sir.
Okay. Maybe I'll write down the question numbers and.
8 and 10, sir.
Okay. Question number. So my screen is visible, right?
Yes, sir. Yes.
1,
3,
3,
8
8,
and 10, sir.
10.
9 also.
Yeah, 9 also, sir.
Okay. 9, 10. Right? Okay. 5. 5. I think 5 is easy, right? 5, 6, 7, 8, 9, 10. 10. 11th question. No doubt. Conditional probability. Okay, maybe I'll
Yes.
solve 11 also because I think these are the topics which, because these are very important topics. I think I have shared an announcement with all of you that the most focus will be on week 9 to 12, right? For the end term exam. So around 60 to 70% of weightage belongs to week 9 to 12, and the remaining questions will be coming from week 5 to 8 and 1 to 4. Okay. One more thing, I think throughout the week, the TAs maybe they have discussed with you that the geometric distribution, one question from geometric distribution is going to come in the question paper, even though it is not covered by Usha ma'am in the lectures or where or throughout stats and syllabus. But I think it's a fairly easy question, and it will help you while going or entering into stats too. So geometry distribution is one of the important distributions. So it's
Sir,
there.
sir, can you discuss one or any one in this session? Any one geometric
Sure.
distribution?
Yes, sir. One
Sir,
or two.
question number 12, sir.
Sorry. Question number 12 also. Okay. Okay. And one question on geometric distribution, right? I think one PDF is shared with you. Maybe I'll take one of the questions from there itself. So geometric, okay, while talking about geometric distribution, I'll come to later part. So it's a family of Bernoulli distributions only, right? So
Yes.
Bernoulli trial is there. So when you toss, or Bernoulli distribution is what? When you toss one coin, you'll have only two outcomes, either head or tail. If you do this successively, it will become binomial distribution, and it's one of geometric distribution is also one of the cases of successive trials, successive Bernoulli trials, where we are focused on first success. So let's say if you have defined head as a success, we'll see in how many outcomes that first success will come. If you have n number of trials, and if you say only one success is there, then what is the distribution of it that covers under the geometric distribution. We'll see that also. Okay, Sure. Okay, then I think we should start.
But is there a PDF for the solution, explanation for the solution of the mock test? Enter.
It's not there. I think it is not. I don't know like, if it is available or not. I am not sure about it.
It's not released, sir.
Okay, but that is fine, I think, right? So anyway, I'm going to solve the questions. Mostly, I will cover all of the important questions here. So I don't think uh, that will be needed then.
Okay, sir.
Okay, okay. Because see, solutions we can provide, but I think again it is not useful when you will try to attempt by yourself, right? See, that is a prime goal, right? What happens, what we have seen earlier also is like if you give the solutions for everything, students don't attempt or don't solve by themselves. So that is the
No, sir.
problem.
I want to just cross check, sir, only.
Yeah, I understand. So you have the question, the answers right, and another thing is we are having the sessions to uh, check like cross check all the queries. Like see
Okay, sir.
whatever approach is yours,
Yes,
will
sir.
it be correct or not? Okay, okay. So let's start then. Let x be a discrete random variable having the following probability mass function. So okay, with the probability mass function, that means it's a discrete variable, right? Discrete random variable, and this probability mass function is given here. This is in terms of one formula, right? So it is k into 3cx upon 3c 3 minus x, and x is taking values 0, 1, and 2, and the value of k. So here, so x takes values from 0, 1, and 2, right? And what is the PMF? The probability that x will take these values is equals to k into 3cx upon 3c 3 minus x, right? Now let's what does this mean? PMF, probability mass function. We can form a table with this, right? So generally, how will you form the table? X equals to x and probability that x equals to x, right? And x will be 0, 1, and 2, and you will have the corresponding probabilities written here. So we do not know currently what are those probabilities because we do not know the value of k, right? Even though we can replace x with 0, 1, and 2, we need to find the value of k, and then we'll be able to complete this probability mass function table, right? Okay. So what is the property of probabilities? So it's like, or what is the property of PMF? So sum of all the probabilities associated with the corresponding values of the random variable, the probability it should be equal to what? 1, right? So let's say that means what, probability that x equals to 0 plus probability that x equals to 1 plus probability that x equals to 2 should be equal to 1, right?
Yes.
Right, okay. So then if you wanted to uh, replace this x with 0, what will be the probability that x equals to 0? It will be k 3c0 upon 3c. 3 minus 0 is how much? 3, right? 3c0 3c3 plus probability that x equals to 1 will replace x with 1, so it will become k into 3c1 upon 3c. 3 minus 1 is 2 plus k into 3c2 upon 3c1, which is equals to 1. Okay, so we can take k common. What is 3c0?
1, sir.
1. What is 3c3?
1.
1,
Again it is 1, right? Okay. What about 3c1?
3.
3,
What is 3c2?
3.
3.
3, right?
Yeah.
Everybody is comfortable with this. See,
Yes, sir.
3c1 is nothing but 3c2 actually, if you see correctly. So it should be equal to 3c1, because this is the formula, right? 3cx equals to 3c3 minus x. So you can directly observe that thing also. It's not, you can have that ratio as well. So what is 3c2? Again 3
3.
and 3. So if you see, the ratios are 1, right? Okay, then okay, I have to go to next page. So this is become k into 3, right? Because this is also 1, this is also 1. So k 3k equals to, so it is 3k equals to 1, which means k equals to how much? 1 by
1 by 3.
3 or 0.333, like this, right? So that should be your correct answer. That should be the answer for question number 1. And if let's say if you wanted to finish this PMF table, what will be the values then? K into this 1. So how much it is? 1 by 3, right?
Excuse me, sir.
Again 1 by 3, and this is equals to 1 by 3, right? Yes.
Excuse me, sir.
Yeah.
I think questions are shuffled in different sets.
Sorry.
Because for me, this is not the question number 1.
That is okay. That's fine, right? It's okay. But this question will be there somewhere else. Right? But I don't think so.
But as
These are
we
not the
go
shuffled
as per the, let's say, this was not my doubt for the question number 1. In my set, question number 1 is different. So
I don't think so, because this mock interim exams, right? The questions are not shuffled, I guess.
So they are shuffled actually. They are shuffled.
They are shuffled.
Yeah,
Okay.
they are shuffled.
Yes,
Okay.
sir.
No issues. No issues then. We can. Okay. Okay. So the problem is you are saying that if I go like this, this will not be the order, right? Or
Correct, sir.
this might not be the questions. Okay, fine. Tell me if that question is there, like that question is there in your doubts or not. So let's say this question number 3 is there. So tell me if you wanted to.
Yes, sir. It's the same question, sir.
Okay, fine, right? So shall I go with this solution or what?
Yes, sir. Yes, sir.
Yes.
So question 3 is a doubt for a lot of people, right? So that's what I wanted to know. So the question number which is I am seeing here, maybe that is a doubt for a lot of people, even though the number in your question paper is not safe. Okay. Okay,
Yes, sir.
fine. Okay, so
So
let's
have you added that question, Sam and Nina?
Your voice is very low. Can you just?
Have you added that question, Sam and Nina? Sam and Nina played a dice game. Have you added that question?
Sorry, I'm not able to understand you. Maybe some.
Yeah, you're not audible, Chetan. You'll have to.
Sir, the question from Sam and Anina, the game,
Okay.
that question he is asking for.
Which one?
Sam, number, I don't remember the number.
Question.
Sam and Nina,
Question.
they.
The next one.
Question number 9, sir.
Nine, sir. 9.
Okay, let's see the question number 9 then. See why I was coming through this line is because okay, fine. Okay, question number 9, right? Okay, let's see question number 9 first. Okay. So two players, Sam and Nina, throw a pair of dice alternatively and independently. Okay. Sam wins if he throws a sum of 6 points before Nina throws a sum of 7 points. So when a person or when someone throws a pair of die, you'll have two numbers, right? Like on two different faces, and the maximum sum will be what? 12,
12.
right? 6 and 6, 12, and the minimum sum will be 2. So when you throw a pair of dice, your sample space will become, and when I'm saying if the if you are interested in the sum of the numbers on the two faces of the dice, in that case the sample space will become 2, 3, 4 up to 12, correct?
Yeah.
Okay.
Yes, sir.
But here the two players are different. When Sam throws a pair of die, he will observe a different sum, and when Nina throws a pair of die, she will observe a different sum, right? But the point will come when someone wins, is when Sam got a sum as 6, he will win. If Nina got a sum of 7, she will win first time, right? Okay, so this is the scenario. Then, if Nina begins the game, then what is the probability of Nina winning the game? So this is okay. Again, I think this is a question of
So it's
geometry.
straightforward. I think what you have to do is you have to list down all the options in which Nina wins.
Yeah.
That 6. There are 6 out of 36.
Yeah, just a second, Karthik. My doubt was in the particular question, I was able to solve the question. There was a twist on this question that I read somewhere, that what is the probability of getting a sum of 7 before a sum of 6?
Same thing, right?
It's the same one, right? If Nina starts, then you
She
have
will get a sum of
Yeah.
7.
Just a
But
second.
okay, but I think okay, so that's fine. Maybe this question also is not like I don't think it's only
this is
6 by 12.
little related to geometric progression.
Yeah, it's a geometric progression, not little.
Karthik, I mean,
It's a geometric distribution basically,
Yeah.
right? Because you cannot directly tell the answer. That's what I feel, because see, it's kind of this, right? Okay, it cannot be a geometric distribution also, because okay, let's
Sir, it
see.
can be, right? So the
It
first
can
time,
be, but but here the two different people are there, right? So in the geometric distribution case, what will happen? I'll have only one coin toss, right? And I'll do it repeatedly. It's a pair of players, but they are doing it repeatedly.
correct. But
So
you
Sir,
get
I got it using geometric distribution.
yeah, it will see. It will look like a geometric distribution. That's what I understand. That's the correct thing, right? See, let's say P is the probability that Nina wins, right? And then what will happen to if and
Probability of Nina winning is 6 by 36. Probability of Sam winning is 5 by 36.
Okay, so okay, that we also can write down as, let's say Nina
6
wins
by,
is how much?
6 by 36.
Why? Because there are only 6 possibilities, right, out of the
36,
36
sir.
possibilities,
Correct.
right? So this is 1 1 1 2, like that. If you note, write down all the, it will become 36 total possibilities, and in which the sum of how much? 7 will occur, right?
7, sir.
Yes.
So it will be, I think, 3 4
6 2 5 4 3
1 6, sorry, 1 6, then
6
I think
1.
2 5
5
2
2
5
2
3
5
4
3 4 4
4
3.
3 5 2, and yeah, like that. So it will
Right.
become 1 by 6. What is the probability that
she
Sam
loses.
wins?
That is
Or
5 by
Sam wins?
36.
36.
5 by 36.
Yeah, 5 by 36. Okay. So what will happen if the Nina starts the game? So either she
6
will
by
win the game.
36.
So she will win the game. She will win first game, say, let's say, right?
Yeah.
Or she will win in the second chance, or she will win in the third chance, like that, right? So if
Yes, sir.
she wins in the first, that means it is become 1 by 6, right?
Correct.
In the second attempt, that means first attempt,
Both lose.
yeah. So what will be the probability then?
30 by
30
36.
by
35.
36 and
31 by
31 by
36.
36.
5 by 6.
So it's 30 into
5 by
36
Okay, maybe I can write down as 5 by 6, right? So it's 1 by
5 by
5
36.
into 31 by
into
36
31 by 36
into 31 by 36 and
into 1 by
into
6.
1 by 6.
Into 1 by 6.
1 by 6. Okay, right? Third, in the third attempt, that means first is Nina, because Nina is starting the game, so she will loses 5 by 36. That means she'll not be able to
5 by 6, sir.
5 by
get
6.
the,
Sir,
sorry,
5 by
5 by
6.
6. Yeah. Okay. Right. So that means she's not able to get the sum of 7. Then, and uh, Sam is not going to right. Okay. In the second chance, what will happen?
Same thing.
Same. Both lose.
So this is 5 by 6 into 31 by 36 into, now in the third.
1
So
by
this
6.
is, so this is first game, right? This is second game, right? And in third game, she will win. That means it will become 5 by 6.
1 by 6.
1 by 6.
Sorry, 1 by 6. Yeah, okay, that's. So what will be the common ratio here?
5 by
I
36.
think, see, this is a common ratio, right?
5 by 6 into 30 by 31 by 36. Yeah.
6 is a common ratio. And so this is, let's say this is R, right? And I can take 1 by 6 common. It will become 1 plus this R plus this will become
R
R
square.
into R. So it will become R square, then R cube, and like this. So this is geometric progression, right? So if the ratio is R is less than 1, then in that case it will converge to, it will converge to 1 upon 1 minus R, right? So it is actually A upon 1 minus R, but A is 1 here, so it is 1 upon 1 minus R. So it is 1 by 6 into 1 upon 1 minus R is what? this 5 by 6 into 31 by 36, right? So this will become 5 by 6 into 31 by 36. So I think if you do the calculations, you will get the answer.
Yes, sir.
Yes.
It's 0.597.
So can you solve the previous the problem before this one in your sheet?
Which one?
If you go back to the question paper.
Okay, but everybody is clear with this, right? Okay, before going there, everyone is fine with this.
So my doubt was this particular question before everybody started talking. I was able to finish. Actually, I read the question that was quite similar to this one. In that, they asked that what is the probability of getting a sum of 7 before a sum of 6? And I thought it's similar to this. I tried that, but the answer wasn't coming. The answer was something very different. And
so you might have to consider both the situations. I think one where Nina starts first and one where Sam starts.
I actually did. I actually tried that. Don't assume that I haven't tried that. I have tried
Okay,
that.
no, okay. Don't. Yeah. So okay. The thing is, can you tell me the entire question once again? If you can read the question, it will
Sir,
be better.
I don't remember that question because I'll try to find that question, and if I find that question, I'll mail it to you.
That's fine, because see, what you are saying based on this creating a scenario and writing down the answer, I don't feel it's a fair thing, right? Because see, maybe you are saying that 7 comes before 6. That's the question, right?
Yeah.
But is it the same scenario which is there in the question, or is it the different one that you will be able to understand once you have the problem statement?
Sure,
So just,
I'll send you this question.
yeah, please. If you find it, I will solve it. It's not a problem.
Yes, sir. Can you please solve the one before this now?
Yeah, sure. So, which one? Question number 8. John parked. Okay,
Yes,
so
yes,
John
yes.
parked his car among 10 cars in a row in a mall parking, not at either end, which has a capacity of 11 cars. Okay, so there is a car parking which is having capacity of 11 cars. Uh, okay, it's already 10 cars in a row. It is given, right? In how many ways is it possible that on his return from the mall he finds that exactly 5, including his car, of the 11 places are still occupied if both neighboring parking lots around his car are empty? Okay, so the question is, John parked his car among 10 cars, row in mall parking, not at either end. Okay, so we'll see. Maybe I'll write this 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10 and 11, right? So the question is, what he has parked his car among 10 cars, so that means already there were 10 cars are there, and he parked his car among those 10 cars but not at either end. What does that mean? That means he
His
didn't
cars
park
are
here,
included, na sir?
11 parking slots are there and both ends are not occupied.
so that means no, the both ends are occupied, that means, right? Because see, out of the 11 slots, 10 cars are already there. He has parked the 11th car. What does that mean? But he didn't. He is so these two positions are not available. That means these two positions are already occupied by any of the car, right? Any other car, right? So he
Sir,
has, yeah, he
excuse
has
me,
left
sir.
with this 9 positions, right? Yeah.
Sir, can't it also mean that his car is not parked at either ends?
Yeah, that's fine, right? That is what his car is not parked at either ends. That is the same meaning, right? That means his car is parked where?
So somewhere in the middle 9 position.
Somewhere here, right? The same thing, right?
Okay,
Okay,
yes.
whatever you approach is the same thing, right? What does it mean is the same. That means his car is anywhere. He has parked maybe here, or maybe here, or maybe here, or maybe here, like this. So how many ways are there? He has parked, and okay, so that is the different thing. Maybe let's okay. So there are actually 9 ways, right? He can park his car among this, but I don't think that is our question problem. So he has parked somewhere here. That is a scenario currently. Now, second thing is, in how many ways is it possible that on his return from the mall he finds that exactly 5, including his car, of the 11 places are still occupied. But if both neighboring parking lots around his car are empty, what does that mean? Let's say he has parked his car. Okay, I'm telling you the scenario maybe. So let's say he has parked his car here, right? Correct?
Okay.
Okay, then this slot, nobody is there. These cars, these slots are empty, right?
Yes.
Right. And in the remaining slots, so how many slots are remaining there?
8.
6, sir.
8.
How 6? 8, right? 3 are gone.
We
8 are
will
there.
take it as a single block, no, sir, because all the 3 are occupied.
The 11 positions, 3 are have been eliminated, so there are 8 remaining.
8, right?
No,
So
but
see,
either end can we can't use either end, right?
why?
The first
No.
and the last.
Back from the
It's not like that. It's not like that. We
First,
can't
sir,
use.
first and last is one is not available for him, but others can park.
Right. So okay. So I'll take the another situation where, see, his car is already parked somewhere, right? In the first scenario, it means that his car is already parked somewhere, right? Okay. So let's say he has parked his car here, right? Correct.
Yes.
Yes, sir.
And now when he returns from the mall, this slot is empty and this slot is empty, and in the remaining 8 positions, right, in the remaining 8 positions, how many cars should be there? 4, right?
8.
4.
4, right?
Yes,
Because
sir.
Yes, it's 4
including his
after
car, there are total should be 5
4.
cars should be present.
5
So here,
cars.
right, so remaining 8 positions, there should be 4 cars should be present. So it can be achieved through 8C 4 ways, right? Right.
Yes,
but
sir.
but one more thing is, he can park his car in how many ways?
9C1.
So he can if he parks here, if he parks anywhere it is possible, so it is 9C1, right? You're understanding the problem?
Yes, sir. Yes.
Yes, sir.
Yes,
Right?
sir. Got it. Yeah.
No, but
So,
sir,
huh.
we also will have to divide by 5, right?
Divide by 5 for?
So, for example, say he's parked the car at the second position, okay, and say there are 4 more cars in, say, 4th, 5th, and 6th position, for example, right? So that's one combination of the cars being occupied. Now, say if he parks the car in, say, so I said second position, his car is parked, and 4th, 5th, 6th, and 7th position, 4 other cars are parked. And in the next combination, we get that on 4th position, his car is parked, and on 2nd, 5th, 6th, and 7th position, some other car is parked. Then would that be considered as the same combination, or would it be different?
Okay, so the question is actually, see, if you see the question, maybe, okay, I'll go there. So this first part, right? John parked his car among 10 cars in a row and not
Correct.
in the lane which has a capacity of 11 cars. So that means he has already parked the car somewhere somewhere in the middle, right? That is the situation. So that means we are surely known that John has parked the car somewhere in the 9 positions, right? The remaining 9 positions, because he can't park the car in both the other corners, right? So we already know the position of John's car. Now
Correct.
we wanted to just find out that there should be 5 cars remaining, including his car, out of the 11 positions. So how
Correct.
we are going to achieve this is through this only. In the remaining 8 positions, how many cars should be present? So this is the first information is actually a pseudo information, which is we are not going to use anyhow, right? See,
So even if we solve with this method, I don't think we get the correct answer.
Why? 8C4 is the correct answer, right? No?
So it's only 8C4. Is it 8C4 or is it 8C4 into 9?
No, 8C4, 8C4.
9C5 it should be, like these three should be considered as one.
No, but
And
how would it give you? How would it give you the correct answer? Because if you select, say, as I said, right, if you select the first position, so if this in this case, if the second position is occupied, any combinations of different 4 positions.
Okay, I'll tell you. I'll tell you how this is correct. So let's say you're saying that let's say if I park the car here, right?
No, you cannot park the car there, right? That's
Yeah. So that is the condition, right? But let's say remove that condition. Let's say okay. First of all, let's say why we actually this first information is given because see in how many ways it is possible that on his return from the mall he finds that exactly 5 of the 11 places are still occupied if this is think about this, if both neighboring parking plots around his car are empty, if this information is not provided, right, the first statement, then you are not able to or maybe you have to come up to this by your intellectual that how we can achieve this statement if both neighboring parking, see what does that mean?
Yeah.
I cannot park here because you do not have the left side space to be empty, right? Or I cannot park here because the right side
so
position
that I got. So my problem is that we are saying that in how many ways can we have. So basically what I'm understanding from the question is if he suppose say parks at the second position, right? Now there are 8C4 ways in which that parking remaining 4 cars could be populated. In that, okay,
Yeah.
in that 8 positions.
Correct.
Now that is because he's parked his car at the second position. What if he parks his car at the third position?
Okay. Let's say let's say he has parked the car at third position. Still, how many ways
That's
are there
why I
to occupy
suggested.
that is going to be 8C4, yes, but then we have a new set of, so that is 8C4 plus 8C4, and that we can do 9 times because there are 9 places in which he can park.
Sir,
Right?
in this scenario, shouldn't we take 9C5? Because
no,
9C5 is not the correct thing because
Sir, actually, in the one of the classes, what 9C5 is actually
9C5
logical,
is correct,
sir.
right?
Yes, sir.
No, but 9C5 is also the same thing, right? 9C5 is what 8C4 into
9C5 won't give you the correct answer because 9C5 does not take into consideration that the 2 places next to that car needs to be empty.
No.
That is what it is taking.
They are making
actually.
it as one.
Yeah.
As a one
unit. Okay.
Taking this 8 plus 1, 9 and 9C5. That is the scenario they are talking about, which is nothing but the what you are talking about, right? Which is 8C4 into 9C1, right? But what I feel is when I already know that one car is parked somewhere, right?
One is parked.
So it is already parked somewhere.
So that is, sir, but that combination is after you decided that you want to park at this position. It does not take into consideration the different combinations where you can park.
See, this is actually a conditional thing, what I feel, because when I say John parked his car among 10 cars, right? What you are talking about is, let's say, I do not know where he can park, and then what will be the position.
So in my case, I'm saying that either the entire combination needs to be where he parks, and after that, what happens, or the that is given is that he selected one position. Now, after that, how many ways can he have? That there are 5, only 5
got your
cars.
point, sir. Got your
So
point.
these are the 2 different scenarios actually. So one thing is, and what I'm saying is, whatever you're saying is not wrong also. But the thing is, since I know one position is already fixed, that means I have remained only with the remaining like 8 positions, and I have to fill with those positions with 4 cars, right?
Okay.
When this will be true, what you are saying is, when I said that there are total of 11 positions and John has to park the car in such a way that there should not be the neighboring parking lots, they should be empty, right? Along with the another remaining 8 positions, we have 4 cars at least. So total of 5 cars should be there in such a way that John should so the neighboring plots around the John's car, they should be empty. If that is the scenario, right, that means I do not know where John can park the car. Here,
Got
what is happening? It's already been parked, right? John parked his car among 10 cars. That means the one position is already fixed. That can be second, that can be third, that can be fourth. So that means it's a conditional one, right? I know.
Yes, sir. Yes, sir. We are calculating
Constraint.
the
We are
different ways.
constrained.
We
Right.
are calculating the ways how 6 cars can be taken away, actually.
Correct. So,
Yeah.
No, but
is it
the
clear now?
question, I got this thing, but it's very confusing from reading the question whether to take that 9
Right. So okay,
position.
it is a different one actually. See, it's not. Yeah, I cannot say you are wrong or I can say, but this is the essence of that question, right? Okay.
Okay.
So there might be some questions.
Sir,
See, permutation combination, it always nobody can say like we are
sir,
perfectly
one
fine
thing,
in
sir.
So in this, so in
Excuse
the
me,
same
sir.
permutation.
Sir,
Yes.
one
Please
thing I
tell
want
me
to
your
ask.
names and and just ask because I'm not able to see your names. Yeah.
Sir, I am Sudhir. I want to ask one question.
Yes.
On this problem only, sir.
Right.
Sir, in this 8C4 into 9C1. Okay.
It will be 126.
No, sir. Question is not that actually. 9C1 is taking care of, we are choosing 11 places. Out of 11 places, 2 are not available, right? For parking. So we are taking 9. Okay. 8C4 is taking care of when he's returning, including his, excluding his vehicle. 4 are more there. From 8 places, 4 places are chosen for that. One part I am not understanding, sir. Which part is taking care of that the places are vacant on either side of his car?
Okay, so when we are saying okay,
because it is there mentioned that when it returns,
correct.
Then how we can say that out of we are choosing 4 places out of this 8 that one of the places is not beside his car.
Correct. So I'll tell you that. So how this is happening is, let's say these are the 11 positions, right? Okay, maybe I'll 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, right? So when I say the two plots should around this car, right? So let's say this is John's car, and I'll say these 2 plots are empty. When this will happen? When this thing will happen? When the John's car will be at this position, at this position, at this position, like among until this rate, because if his car is here, you cannot have any empty space on the right side. If his car is parked here, that means we cannot have the empty space on the left side, right? So you just make it as one unit, right? And one unit will occupy how many places?
3 places.
3 places, right? So they can be either of these 3 places, or these 3 places, or these 3 places, right? Like this, or until what point? Until these places. So if the 3 places are occupied, I'll have 8 places remaining, right? And in that 8 places, I have to choose 4 cars. So when I say 2 neighboring plots are occupied, you just consider them as one unit. It will automatically taken care of that condition where I'll say the two.
So if 2 neighboring places are occupied, then only there are 5 cars, including John's car.
5.
Suppose we shuffle, only 5 cars are there. And if we place a car beside the John's car, then also there are also 8 places. Vacant 8 places.
Sorry, what was your question again?
Okay, 1 minute. I'll just. Yeah, tell me 1 minute. Sorry, I was not.
If sir, if we are going by vacant place wise, so choosing these 8 places, we are choosing 4 places from this 8, right? So if we shift a car, which we are now assuming that the places on either side of John's car are vacant. Suppose we shift a car to that vacant place, then also there are 8 places vacant. then this is not taking care of that the places are vacant beside this.
No, I still okay. Maybe I'm not able to so you are saying that you can shift this car to this place.
Suppose, sir, we are counting for 8 places, right? Because we are taking 3 places for John's car, one for John's and either 2 are vacant beside his car. But suppose there is a car out of these 4 parked beside this John's car, then also that place from where that car is shifted to his side, John's car, that part is vacant. Again, 8 places are vacant.
You are saying some other car can come into this position like this?
Yes, sir.
No, how can it is not going to? That's what we are saying, right? We are going to fix 3 places first, right? These are already fixed. Now I remained with the 8 cars that cannot come to this place, right? So 8 places. So that cannot.
That is only my question, sir. That is only my question. As per the answer given, 8C4 into 9C1. Which part is taken?
9C1 is not there.
8C4, this is not the answer. So correct answer is only this. 8C4. This is the correct answer.
Because John's car is that position is not changing. He has already parked it. This probability is calculated on his way back from the mall. So John's car's position is not changing.
See, this
I
is
hope that's what the point is.
Sir. Yeah. So this position is already fixed, right? So these 3 positions are already fixed.
Okay. Now understood, sir. Now understood, sir.
So we have just we are just
only now. Okay. We are now this places. This is reduced to 8 places only.
Yeah.
Only, and we have to choose. Okay.
Correct. Okay.
So 15 also, sir. Same permutation combination.
This one?
Yes, sir.
Okay.
Should be simple, but I got.
Okay, fine. No issues. We'll solve. So, okay, a fruit seller has 6 dozen bananas, out of which 6 dozen. 12 are out. Okay, 6 dozen means like 72, right? 72 bananas.
Yes, sir. 72. Correct.
Out of which 12 are routed. If a customer wants to purchase some bananas and chooses 6 bananas without replacement, then how many rotten bananas can expect customer? Okay. Okay, fine. So you have total of 72 bananas, right?
Yes, sir.
And out of which 12 are rotten and remaining are good, right? So how many good bananas
60.
there?
60.
60.
So these are rotten. So I'll mention them as by R. These are the good bananas. Okay. If customer wants to purchase some bananas and chooses 6 bananas, can expect customer. This is okay. This is the expectation problem actually, but this is actually not a permutation. This is a probability question.
It is a hyper geometric.
Yeah, you can do it with hypergeometric or with the simple probability. It's not a problem. So this is a question of probability. Okay, we are going to find out expectation of x. So x is what? X is rotten banana. Let's say I have defined a random variable x as number of what? Number of rotten
bananas.
Yeah.
Okay. So how? So when I choose 6 bananas, or when a customer, or let's say I am a customer, if I choose 6 bananas out of the 72, what my random variable x will take the values. So among these 6 bananas, I can have 0 rotten bananas, right? I can have 1 rotten banana. I can have 2. I can have 3. I can have 4. Up to what?
6.
6, right? This is these are the values taken by x, right? Because I have defined the random variable x as number of rotten bananas. Okay. Now let's try to prepare or find out the probability mass function for this. So let's say what is probability that x equals to x. So what is the probability that x equals to 0? So there are total of so if you don't remember the hypergeometric formula, so it's not a problem. How can you find the normal probability that x equals to 0? X equals to 0 means what? Among the 6 chosen bananas, no banana is rotten, right?
Yes.
sir.
So that means all are the good bananas. So I can have this 66, 6, right?
Yes, sir.
66, right? Because all the bananas which I have taken are from good lot. And out of how much, out of how many I'm doing this?
72.
72.
6, right? This is the probability that I will not get any what?
Rotten banana.
Any rotten banana.
Right. Similar probability that x equals to 1. So what is probability that x equals to 1? Out of
60 choose
12.
5.
Okay, out of 12, I'll get 1 into 60C5 divided by 72C
6.
6. And
So,
like that,
I got all these things, but the thing
yeah,
is, solving this method was very lengthy. So
yeah,
that's why
that's
I
why,
wanted to.
yes. So then that is why this hypergeometric formula comes, right? So what is the expectation of a hypergeometric formula? Hypergeometric distribution. This is a
NM
hypergeometric.
by N. NM by
What is what?
N, M, N into M by N.
So what is N here? N, right? Capital N,
N
right?
is
Here.
6, right? 6. And M is 12.
M is 12.
Yes. Of type, rotten. It's rotten, right?
Yeah, the total number of bananas
divided by 72, so 1.
Divided by 72, right? Okay, fine. So this is 6 into 12 by 12, right?
Got it, sir.
Yeah, or you can do it with this, or you can do with this. Like, but this is, see, this finding these probabilities, it's not a simple task, right? 66 and 72 or likewise. So again, for the probability that x equals to 2, you have to find this, right? So maybe your denominator will be same, but your numerators will be very difficult to calculate, and hence this is the formula which can be used, which is the expectation of a hypergeometric random variable. Okay, fine. Okay, just
So
wait a minute.
capital N is 12 or 72?
72 total.
Okay.
Sir, can you discuss the 14th one?
So you're on mute.
Okay, sorry. Yeah, I was. So let's go to the question number 10,
14.
right? 14.
14. It's
14.
near.
Oh. Okay. The duration of a video game is a the duration of a video game is a random variable with exponential distribution with mean equals to 20. Suppose that when you enter a video arcade, two players are playing the game independently. Find the probability that exactly one of the two will be playing for less than 40 minutes. Okay, so this is the probability you have to find out. Okay.
So these solutions for this mock test, it is uploaded in the system?
It is not available. It is not available.
So will you be sending us the PDF or whatever?
Yes, sir, if possible, if that is available.
Possible, you can send your handwritten thing also, you can send.
This is too bad actually, I think.
But we can still helpful, na? It will be helpful.
Yes, sir. Just to cross check some method also, very specific, sir.
Maybe I'll try. Okay, maybe I'll try to. But how much time we will have actually?
Yeah,
Okay,
still, sir, please, sir, like
okay,
if the solution is there
maybe
for
if
all the
some
questions.
solutions. Okay, if other solutions are available, I'll ask them to 1 minute. I'll just check.
Yeah,
Give me 2
please,
minutes.
sir. Yeah,
Well,
thank you, sir.
check. Okay, so I have told them. Let's see when it will be done. Okay, so the duration of a video game is a random variable with an exponential distribution with mean. So let's say x denote what? X is the random variable which denotes duration of a video game, right? Or time of video, maybe whatever things. So let's say x is that random variable. So you with this you can say it's a duration of a video game. What does that mean? X is a discrete variable, discrete random variable, or a continuous random variable?
Continuously.
Continuous random variable, right? Because it denotes a time. Maybe it is in a minutes, or it is in seconds, or it is in hours, but it's a continuous, because you cannot play in like 1 minute and directly you jump on 2 minutes or 3 minutes, right? You can have 1.5 minutes, 1.2 minutes, or maybe I don't think any game can be played in 1 minute. So it will consume at least 10 minutes of your time, right? Okay, so x is a continuous random variable, and what is the distribution of it? Exponential lambda, right? And one more thing we got to know is the average time or average duration of playing a video game is what? How much it is?
20.
It is 20 minutes. So what will be lambda then?
1 by 20.
1 by 20, right? So that is my lambda. Correct? This correct?
Yes, sir.
Okay, so this is my distribution with lambda equals to 1 by 20. So I can say that this is exponential 1 by 20, right? Now the second thing is, suppose that when you enter, two players are playing the video game, they are independent to each other. Find the probability that exactly one of the two will be playing for less than 40 minutes. Okay, so I don't know, like find the probability that exactly one of the two. Fine. Okay. So okay, I'm not sure you guys have studied this. Have you studied this one? The two random addition of two random variables or something like that?
Yes, sir.
You
One
studied,
is
right?
continuous. Yeah, one is continuous in the graded assignment 12.
Okay, then I think it will. So let's say x1 is what denoting what? The first player, right? And what is the distribution of that player is same, right? And x2 is same, correct? Because that belongs to the same random. See, these are the concepts actually are very useful in the stats 2. Okay, when you enter into statistics 2, it will have that concept called IID samples, right? That means identically independent distributions, right? So identical means x1 and x2, you see their distribution is same, right? Independently, it is already mentioned in the question itself. So these are the IID random variables, but okay, we are not going into that currently. So it's like x1 plays the game independent to x2, and we have to find probability that either of the two, exactly one of the two, has to play the game more than 40 minutes. So what does that mean? Either x1 will play greater than 40, right? X1 or correct, and what? So this okay. First of all, tell me this is correct or not.
In both cases, we should consider
Less
x2,
Yes, yes,
x2
yes.
also, right?
So what does that mean? Either x1 will play greater than x will is greater than 40 and x2 should be
less
than 40.
right? Then only this condition of exactly will come into play, right?
Yes, sir.
Correct. Similarly, what will happen? X2 greater than 40 into x1 less than
40.
40. But one more thing we can observe from here is x1 and x2 are similar, right? Same, right? Because their distribution is same. So I can have directly 2 into any one of these conditions, right?
Yes, sir.
Yes, sir.
This is fine. Or else if it is not fine also, we can actually do the calculation and I think it will come the same. Correct? So if you want to try that also, that is fine. But this should be the scenario, right? Okay, I'm going with this 2 times, or maybe okay, maybe I will remove this. That's fine. Maybe we can see that also. So okay, what is the probability then x1 is greater than 40? This is the distribution. What is the PMF? Shall we use sorry, PDF, not PMF, PDF. So shall we use PDF or CDF? X1 greater than CDF,
1
right?
minus e to the power minus lambda a. Minus
Lambda
a.
Okay, A or X. Okay.
X, yeah, whatever.
Currently, it should be okay.
X1
so this is CDF, right? That probability that x1
less than
it is less than
x,
small x, right? Or maybe small x1, whatever. Okay, maybe I'll write it this way. So suppose x is my random variable. X is a random variable. I'll denote it as by RV. Then probability that x is equal to x. Okay, what is this probability that x equal to x? This is PDF, right? What is PDF of it? E to the okay. Can somebody tell me first? I should.
lambda e to the power minus lambda x.
Lambda e to the power minus lambda
X.
This is my PDF. What is CDF? Probability that x is less than small x.
1 minus e to 1 minus e to the power minus lambda x.
Okay. So here we are going to see x1 is greater than 40. How to find this? Let's say probability that x is greater than small x. It is
1 minus
one minus
probability x less than x.
A small doubt, sir.
Yes, tell me. Yeah.
Sir, can we write x is equal to at a particular?
Your voice. So if you are talking, can you just.
Sir, can we say that p x is equal to at a particular time probability at a particular time probability?
Px equals to at a particular time.
Is it, sir, or this should be greater than? I think greater than.
Okay, greater. Okay, your point is shall I use greater than or but I think see
Yes.
in continuous random variables these inequalities doesn't hold actually. So if I say probability that x is greater than or equal to x, right? Still it is the same.
Sir, this doubt is connected to one previous doubt because in case of there was a problem for Shatabdi Express reaching exactly at a point, I think answer was 0.
Yes, because we cannot find in continuous random variables, right? Let's say I will take this distribution itself. If it is exponential distribution, right? So in continuous distributions, you cannot find. Let's say this is x, right? Okay, so you cannot find exactly at this point.
Because the area under that at a curve, the area under that curve is 0.
Yeah, generally you have to find like this. You have right. We have to take the small area. Let's say dx infinitesimally small, and you will add because this is the basis of integration, right? This is the this is how we integrate in terms of when we are dealing with the continuous distribution, and hence
so
when
we are writing, sir, I don't understand when we are writing less than equal means we are taking the point till we are talking about till that point, no?
That point or and we are
till
talking
that point.
About we are and generally we are interested up to everything up to this x. So this is complete area, right? When I have some
Okay,
area
okay.
behind me, I'm able to find the area under that curve, right? When I say probability that
Okay,
x
okay.
is less than x, that means everything under this point until this point, right? When I say
Okay.
x is less than or equal to x also, again it will be the same thing, right?
Sir, suppose in multiple select type question, we find option like this,
no,
and one is less than, another is actually equal to. Then this will make the whole concept wrong. No?
Both are correct then. Right?
If we find two options, sir, one is for less than equal to, one is less than, and one is equal to.
You can choose both the
or
options.
Continuous. For this continuous type of thing.
But when it is discrete,
Yes.
right? It is not the case. Okay, discrete.
Yes, yes.
That equality less than or equal to will have the different meanings, right? So
Okay,
in case of discrete random variable, I
this
say probably
exponential is continuous type of thing. Sir.
Yes, it is exponential, right? I told you, right?
This is continuous, no?
Yeah.
Oh, that was only my point. Sir.
Okay. First of all, read about all the descriptions, because these are very important when you go for the or any interviews, maybe if you're going, or any when you enter into stats 2 also, these are the very important things. What are the discrete random variables? What are the continuous random variables? That you should know at least, right?
Okay.
What are the
That was
discrete
only
random
my
variables? Bernoulli, right? Then
yes.
This is the basic one. Then what else? Poisson.
Yes.
Then
Hypergeometry.
binomial. Hypergeometric. Right? Geometric. Right? What else is there? Poisson, Bernoulli.
Normal.
Exponential.
No, normal is not there. So normal continuous distribution is sorry continuous. Sorry. This exponential will come under continuous distribution.
Continuous.
Right?
Yes.
Normal will come under continuous.
Uniform.
Then uniform. So uniform actually both where is there. So uniform discrete will be there, and uniform continuous will also be there, right? But in our case, we have studied, I think in stats 1, we have studied about uniform distribution, which is the continuous distribution. Okay?
Yes.
Uniform can come under the discrete also, and the formulas will not be same. So in this case, I think it is 1 upon b minus a. If I wanted to find probability that any x is less than or equal to x, or equal to x, right? So this is the PDF for this uniform continuous. But for this, it's not the same thing, because it will be like, let's say, what is the uniform distribution? What is the uniform example? So in example of uniform distributions, we have seen every time is, let's say you have thrown a die, okay, and let's say getting the values, right, are equally likely, or getting a number on a top face is equally likely. So what is the sample space here? 1, 2, 3, 4, 5, and 6, right? When I throw a die, and if I say they are all equally likely, that means everyone is having the same probability. So this is the case of what? Discrete uniform random variable, right? Correct? Right or not?
Yes.
Right? So how did you find this probability? It is 1 upon total number of outcomes.
Favorable outcome by total outcome.
Right? So this is the probability. This is the PMF actually, for uniform distribution. So at least you should be aware of these things, right? There are some more continuous random variables, which are like maybe relay is there, some other distributions are there. We are not going to see them, but at least these are the basic random variables we should know of. So in the discrete, Bernoulli, Poisson, binomial, hypergeometric, geometric, uniform, those you should know. One more is I'm actually missing, but I'm not able to recap it, which is very related to is exponential, Poisson, and one more. Okay, but yeah, at least you should know this. Okay, so yeah, I spent one. Okay. Now where we are, Okay, so let's okay, maybe I'll write it down again. Let's say x is exponential, x is exponentially distributed. What is the PDF of x? It is
lambda e
to the power minus lambda
x.
Okay, what is CDF of x?
1 minus e raised to minus lambda a.
X or a. So when I say a is when I say x equal to a, right?
Less than or equal to, yeah. No,
So
it's less
I'm
than
just
or
saying that. Sorry.
less than or equal to a, right? Probability of x less than or equal to
Yeah. But what I'm trying to say is when I find instead of small x, if you are using a,
yeah.
it's fine. That is what I wanted to say. So okay, what does this mean? It is probability that x equals to x, right? This is what probability that x is less than x.
less than or
So if I
equal to
wanted to find probability that x greater than x,
1 minus
1 minus
probability
probability
of
that,
x less than or equal to,
right? This is from properties of probability. So this will become 1 minus e to the power minus lambda x, right? So this is becomes what? E to the power minus lambda x, correct?
yes.
Yes, sir.
Fine. So we'll make use of this here.
Sir, when we will use lambda e power minus lambda x? Means at a point if I ask for.
At a point, actually, the probability is equals to 0, right?
So means
this is the PDF of x. So when
when
I
to use
say
PDF?
around x, if I wanted to find the probability around that point, so but generally it does not have any use of series. So when we wanted to find the probabilities, right, we'll use the CDF generally for the continuous cases. Okay, PDFs are not we are not going to use for finding the probabilities. Okay, so yeah, so this was my question. This is the answer, right? So this is what we have to we wanted to calculate. X1 is greater than 40 into x2 is less than 40 plus x1 x1 less than 40 plus into x2 greater than 40. This is what we are interested in. Okay, what is x1 greater than 40 then?
1 minus
E to the power
minus 40 minus lambda
40 by 20, right? So
minus
right,
2
right, into x2 less than 40 is what? 1 minus e to the power minus 40 by 20, correct? Plus x1 is less than 40 means 1 minus e to the power minus 40 by 20 into e to the power minus 40 by 20, right? So this is same, right? I can do it is 2 times e to the power minus 2 plus or not plus is into, right, into 1 minus e to the power minus 2, correct?
yes.
It's fine.
Yes.
Sir.
Sir, I have a small query in one of the question. May I ask?
One minute, I'll finish the solution and then we can,
Okay, sure. Yeah.
2 into this e to the power minus 2 minus e to the power minus 2 into minus 2, like e to the power minus 2 into e to the power minus 2 is how much?
Minus 4. E to the power minus 4.
Everyone is okay?
Yes, sir.
Okay, everyone is only 2 people who is saying yes. Okay.
No, yes, sir. Okay, sir.
Yeah, okay.
Yes, sir.
Everyone is
Yeah,
fine?
we have
Yes, sir.
understood.
Yes, sir.
Okay, done. Okay, thank you. 2 into e to the power minus 2 minus 2 into e to the power minus 4, or I can, so I don't know which is the correct option. 2, okay. So 2, okay, maybe I can take, I think they have given the solution until this point, right? This is 2 into e to the power minus 2
Yeah.
into 1 minus e to the power minus 2. Okay, either of these 3 solutions are correct.
There is PDF solution also updated, uploaded.
I have asked maybe let's see when that will be done. Okay, I just called them. Let's see. Okay, where this is done. Okay, what is the doubt then? Where?
Sir, I have a doubt in one of the line in question number 7.
7. Okay.
Yes, sir.
Question number 7. Okay. What is the question? Maybe this is not the same.
Yeah, this is the same.
Robber.
This is
Okay.
the same question. So, I mean, I got confused with the second line where it says that the robber will not use the keys that did not open the lock in the upcoming trials. So, I mean, that's where I was confused without replacements or what it is. And then.
Okay. A robber who needs to open the lock of a house has 21 keys, out of which only one key can unlock the house. Okay. The chance of selecting a key is equally likely for all the keys. Fine. Okay, that is random, right? Okay. The robber will not use the keys that did not open the lock in the upcoming trial. The robber will not use the keys that did not open the lock in the upcoming trial. Yeah, I think it is without replacement. So let X be defined as the number of trials required. So for in the first trial, what is the probability that he will unlock the
1
house?
by 21.
1 by 21.
Yeah.
In the second, if he goes for second, that means he is not able to open in the first trial, right? So it will be then what? Okay,
20
what
by
are the
21.
possibilities? He will open the lock in the first trial, or he will open the lock in the second, or he will open the lock third, like this, right?
Yeah,
In the
right.
first case, it is
Yes,
1
sir.
by 21. In the second case, that means he's
20
not
by
able to open
21.
in the.
By 20.
1 by
It
20.
is 20 by 21, right?
20 by
First,
21.
1 minute. 20 by 21 is why he's failed to unlock, right?
1 minus 1 by 21.
Right.
20.
In the second case, it will be
1 by 20.
1 by 20, not 1 by 21, because
By
he's not
20, yeah,
going to
correct.
use. So in this third means 20 by 21 into 19 by 20 into
20.
1 by
19.
19. Correct?
Yeah.
Everybody is okay until this point?
Yes, sir.
Yes, sir.
Yes, sir.
Right. And likewise, this will go. So if you see, this 20 will get cancelled.
Yeah.
This 20, 19 get cancelled. So
Yeah.
I think he'll left with, in the first attempt, it is 1 by 21. Again, it is 1 by
21.
Again, it is 1 by 21. And I think every time is 1 by 21.
Right. Yeah.
So I think it is 1 by 21 into 1 plus 1 plus 1 plus up to n.
Yeah.
Or maybe 21.
Sir, it will be 1, 2, 3 means
So
as the X is number of trials given in question.
Sorry?
So a random variable X given that number of trials in which he opened the door. So it will be 1, 2, 3 like this.
He's asking the expectation.
Okay, so let X be defined as the number of trials. Fine, right?
Excuse me, sir. Excuse me, sir.
So these are okay. 1 minute. So X is what? 1. X is 1 means he has unlocked the door in the first trial, right? X equals to 2 means how much? What does that mean? In the second trial, he is able to do that, right? Like that. And I think this is the expectation, right? No?
Okay, no, expectation, I think we have to multiply.
Okay, expectation, then we have to multiply. Yes.
This is the probability, so okay. I got
Oh,
that.
sorry. This is okay. For expectation, you have to multiply with 1 into this. Okay, sorry. So if you, I think
21 by 21 plus 2
I
into.
think I think this is not the answer. Sorry, I missed that part. Okay.
Sir,
So
1 by 21 into 1 plus 21. The sum of 1 plus 21.
Sir, can I explain the different way of follow?
Hi, yes, 1 minute. Just give me. I'll finish it. I think this should be the correct one, right? 1 plus 2 plus 3
up
plus
to 21.
20, right?
Okay.
And this is sum of natural numbers, so it is n upon n. How much? What is the
21 into 22 by 2. 21 into 22 by 2.
21 into 20, right?
22.
Into n minus 1 by
n into n plus 1, sir.
n into n plus 1 by 2. Sorry. Okay. This will get cancelled. So I think 11 is answer. Okay.
Yes.
So if somebody wants to do it in another way, you can.
Yeah, sir. Can I go ahead?
Yes, please. Yes, please.
Sir, I approached this problem in different way. It is there are 21 keys, right? Hello.
Yeah, go ahead. Go ahead.
There are 21 keys, and there are chances that you can open first go, second go, third go, fourth go, and last go.
Yes.
So here it is asked. He is asking for the expectation, and expectation is kept.
Yes.
So total number of attempts is 1 plus 2 plus 3 plus 4, like 21. That is n into n plus 1 by 2, and divided by the total number of keys that comes. The same answer is, sir, the calculation is same what we have written on the.
Fine.
Can I approach in this way, sir? Is it okay?
Yeah. Same thing. This is correct, right? Okay. So, any other question? 10th, I think somebody has asked for 10 also, right?
Question number 5, sir, in entrepreneur.
5.
Okay, we have 12 after this.
This one, entrepreneur.
Yes.
Okay. An entrepreneur has invested in 4 startups, but I think this is the similar question which is there in the grade assignment, like this. So it's like similar. Okay, fine. Okay, no issues. Maybe I'll explain, but you guys have to tell me what are the things. Okay, this is a simple one, because if you tell me, then you will be able to understand where you are doing the mistake. Okay, so an entrepreneur has invested in 4 startups. If the startup makes profit, it will yield respective profits of 20, 25, 30, and 40. On the other hand, for each startup, the entrepreneur may not gain profit. He will incur a loss of 10. Okay.
So doubt is here to how to means so the loss, it will be negative, but
no issues. If the probability is that the entrepreneur will make profits from these startups is this, what is the expected profit? So let's say maybe I'll okay, there will be 2 approaches to solve this question, but maybe I use that. I don't know. Maybe it will be a difficult one or a simple one. Let's say there are 4 startups. Okay, X1, X2,
yes, sir.
X3, and X4. Right? They have their own distributions, right? And they are independent to each other. Let's say what is the it can make a profit or it can may have a loss, right? Same thing, right?
Yes, sir.
Right. So there are 2 outcomes to each of the startup, right? So what is the probability that X1 will make a profit?
0.1.
X1 is 0.1.
0.1.
So if he makes a profit, that means what is the probability associated with 0.1? Then what is the probability that the loss is there?
0.9.
9. Right? Okay. Similarly for X2?
0.2.
0.2. Loss?
0.8.
0.8.
Here
0.3.
X3?
0.4.
0.9. But what are the, okay, these are the probabilities associated with this profit and loss. But what will be the value associated with the profit? Or that means, okay, what does that mean? X1 will take value as profit. What is the profit?
20.
20. And what is loss?
10.
So I can consider this as minus 10. Okay, since it is a loss, I'll say it's a negative of a profit, right?
Okay.
Right? What is the probability of, or okay, or maybe okay, generally we do like this, right? So x1 equal, so x1 is will have the probability of 0.1 when x1 equal to 20, right?
Yes, sir.
And 0.9 when x1 equals to minus 10, right? Similarly for x2, I will write the PMF as 0.2 and 0.8 when x2 equal to How much? It is 25, right? 25, right? Similarly, x3 is 0.3 and 0.7. X3 will take value as 30. Right. X4
0.1, 0.9, 40, minus
40.
40.
Okay. These are all 4 different random variables, but the total profit will be what?
Summation of all.
Right. So profit will be, but what we want to find first of all, you just wanted to find expected profit, right?
Yeah.
So let's say x is equal to the net profit. Okay, right? X is net profit. So what is expected value of x? It is expected value of x1, right? Which is nothing but expectation of x1
Plus expectation of x2 plus expectation of x3 plus expectation of x2.
right? Fine.
Yes.
Okay, what is the expectation of x1?
Sir, for x is x2 25 probability 0.3.
What?
Minus 7.
For x2, sir, probability will be 0.3, 0.7.
Okay. 3, 7, 2, 8. Okay. Anyway, this does not matter much. Okay. So expectation of x1 is what?
2 minus 2
What
minus
is
9,
it?
2
Minus 7, sir.
minus 7.
20 into 0.1 minus
0.9 into
right?
Yes, sir.
So this is what?
Minus 7.
2 minus 9, which is minus 7. What about this?
Minus 0.5.
0.5, sir.
Minus 0.
Okay, what about this?
Minus 2.
Minus
minus
2. 60 and this is, sorry, this is 6 and 8.
6
So
and
6 minus 8 is
Minus 2, sir.
this is 4 in 4 minus
Minus 5.
Minus 5. Sir, there that is 0.5, sir.
where?
It will be minus 0.5.
No, it's plus, right? 25
It
into
is plus.
0.3 is 7.5 and 10 into 7 is, okay, this is plus. Okay, so I'll just add all this.
13 minus 13.5.
So yeah, so it is minus 7 plus, not plus, yeah,
Plus
plus 0.5
minus
Minus 13.5.
minus 2 minus minus 5.
5, which is minus 13.5. That will be the expected, is what? Expected net profit, right? It's actually a loss, but yeah. So my he will incur what? How much of loss? He'll incur like minus 13.5 lakhs of loss. So or not minus. So he'll incur a loss of 13.5 lakhs, or you can say he'll have a negative profit of 13.5. So same thing, right? Understand this point?
Yeah.
Sir, can you please discuss the 6th question over here?
Okay. So if the graph of a PMF of a binomial random variable is exactly symmetric about x equals to 5, then the value of p could be, okay, what will be, what is your answer? I think this is already mentioned in the this is, I don't think so. This in the lectures ma'am has covered that, right? It is actually related to that graph of a binomial random variable. So how will you look like? So for that, maybe, okay, maybe I'll draw the graph. You just have to tell me. Have you studied that one, the graphs? Or have you studied the binomial distribution? So let's say You know, right?
If P equal to 0.5, it is symmetric.
So okay, but how this will happen is maybe the graph of binomial will, yes.
So graphs are positive and negative.
Okay, maybe let's say we'll try to find it out. Let's say total n equals to 10, right? And let's say what is the value of probability here?
5.
Okay,
Yeah,
it
at
is not
x
there.
is equals to 5, it is symmetric.
So
Sir,
Sir,
can we say that expectation is 5 because
expectation is 5
symmetric
only,
about 5 because the mean will be 5 and we take expectation as mean. So expected value is 5. So NP is equals to 5. Therefore, P is 0.5. So
but
I
P,
did it this way.
oh, fine.
Because
But
it's binomial now. So NP is equals to 5. So that's why.
Yes, that is correct.
Their expectation is at the center because when it is unstable, the P.
Okay, so I think let's try to find it out. So if I don't know, like maybe I'm not able to hear, or everyone is having the problem.
And what's the problem?
I'm not able to hear. Somebody was trying to say something, and I think I lost in between. I'm audible,
No,
right?
no, sir. No. Yes, sir. You are
Yes, yes,
You're
yes.
audible.
Okay. So you said no, sir. Then I was
No,
like,
yeah, sir. Yeah, sir. Well, actually, my connection was sort of. Yes, sir. I actually said it.
Okay. So here,
Sir, can
let's
we
say.
move? Sir, no. Can we move? I was asking to for 12th question in this paper only mock as. After this, can we take 12th question?
Yeah, we'll do. But yeah, let me finish now. See this. This is the when. Okay. See what happens is like somebody says sir, right? So I will
Yes, sir.
stop.
This
Like I will to
attention
here,
you
and
get.
it
Yes,
will
sir.
take.
Yes, I
Yes, sir.
understand. I
It
understand.
will,
Sorry for
Sir,
interruption.
now you are solving questions. So okay.
So no issues. No. So shouldn't I solve this? See, generally when the probability is 0.5, right? What does that mean? Because binomial is nothing but the successive Bernoulli trials, right?
Yes.
And if you have this probability as 0.5, what will happen is each of the outcome will have uh, 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 only two. See, anyway, Bernoulli is having, let's say, head and tail, right? Only two outcomes possible, and each will have the same probability associated with it. In that case, what will happen when I add all these probabilities? Since what is binomial actually? It is nothing but this, right? NC 0, right, into p to the power
0 q to the power n.
0, 1 minus p q. Yeah, q power n.
N, right? And then NC 1, p to the power 1, q to the power
n minus
1, right? And NC2, like that. So when I have this probabilities similar, so this is what p, and what is q actually? Q is 1 minus p, right? So when I have this similar, how it will go? It will be become like NC0. Since p is same and q is same, it will become p to the power n, right?
Yeah.
Similarly, everywhere you can cross check it, like because the base is same, right? It's 0.5. It's 0.5 to the power 0 into 0.5 to the power n. So this becomes 0.5 to the power. So let's say in this case it is 10, right? N is 10, right? So it is n 0.5 to the power 10. Here, 0.5 to the power 1 into 0.5 to the power 9. It will become how much? 0.5 to the power 10. So the graph is not going to be dependent on these values because these are the common values, right? But
Sir, so for any value of n, the
whatever value will be there, this graph will look symmetric, right? Like this. Maybe okay. This is not continuous one. You will see like this. Let's say NC0 how much? Okay, not NC0. Let's say 10C0 is how much? 1, right? 1. 10C0 is 1. So it will have. So it will be associated with this probability, right? So if I wanted to draw this graph, right? Let's say I'm just going fast, okay, but I just wanted to show you how it will look like. This is not maybe the best time to do this, but let's see. So, let's say these are what x, right? Or maybe the so when I have x equals to 0, that means nc is 0, right? So it is 1 into, let's say this is the probability associated with it. How much it is? 0.5 to the power 10. So I think it's very trivial, but let's say it is having some bar. Okay, this is, let's say, the bar. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. What about 10? And what is 10c10? 1, right? And then it is associated with this probability, right? Again, 0.5 to the power 10, because it become 10c10 p to the power 10 into 1 minus p to the power 0, right? So again, nc0, okay, I'll write it here. nc0, or maybe 10c0 into p to the power 10, 0.5 to the power 10, is similar to 10c10 into 0.5 to the power 10, right?
Yes, sir.
What about 10c1 and 10c9? Again, see, this is same,
Yes,
right?
sir. Yes.
It can get cancelled. So all the bars, if you see, the only thing is it is going to be multiplied with these values, nc1, nc2. So it will become like this, right? So it will like this, like this, like this. Okay. At 5, it will become highest, right? 10c5. And since 10c4 is same as that of 10c6, so the bar will become like this, right?
Yes, sir. It will be
Similar,
symmetric.
it will become symmetric, right?
Got it, sir.
But it will become symmetric only when my probability is equals to 0.5. If my probability is not equal to 0.5, suppose it is, let's say, 0.4, so less than 0.5, this will become 0.6. And nc0 and nc10, even if they are same equal, but the probabilities associated now will be different. Why?
Yes,
Because it will become
because the
0.4
powers
to the
will
power
be
0
different.
into 0.6 to the power 10, right? This 0.6 to the power 10 is not equal to
0.4 to the power 10.
power 10, right? How? So
Yes,
which is
sir.
greater? Which is greater? This is greater.
0.6. Yes.
Right. So what will happen? This
Right
bar will
skewed.
be
It will not be
much higher
symmetric.
than this, right? So
Yes,
it will
sir.
skew to where? Right.
Right skewed, right? Right
Yeah.
skewed.
It will right skewed, right? Because
Yeah.
so what will happen in that
That
case?
point.
So my graph will look like somewhat look like this. So maybe this will, okay, this will increase, right? This will increase up to where? 5, right? But and then again it will decrease, that is for sure. But how it will be decrease, that will be different, right? So maybe
Yes.
currently, so this looks like this, right? In this case, it will look like skewed to like this, okay, right? The bars will
Okay.
be going like this. So okay, it is not going to be maximum at 5, I guess, right? It should be maximum somewhere here, that you have to calculate maybe. And when this is the case, what will happen? When probability of success is greater than 0.5, it will become left skew,
Left skew.
right? So the maximum point will be at some other place. So when it will be symmetric, when p is 0.5, otherwise it won't be symmetric.
Excuse me, sir.
Sir, I have a
Yes.
question.
Sir, when will it be left skewed? I just lost connection, sir. Can you repeat that last part?
When
Left skewed when
greater than
probability of success,
0.5.
when probability is greater than 0.5. Left skewed is this, okay? Left skew means the tail is on the left side. Right skewed
Okay,
is
sir.
tail is on the tail means the smaller probabilities are on the right side. That is, this is right skewed. Right skewed will happen when probability of success is
Less than 0.5.
0.5. This is left skewed.
If n is very
Sir, I
large,
have.
it is always symmetric, right, sir?
For any for same ends, okay? This is not for different trials. For n different, we'll have some other distribution. So see, the probability, I think that it depends on what? N and P, right?
Yeah.
That is why when I write any binomial distribution, I'll write like this, right? So let's say X is a binomial random variable. So the distribution X will become binomial N into P, because this is dependent on these two parameters, right? Similarly, when I write if let's say X is exponential, how will I write the distribution? X is exponential lambda. So here lambda is a parameter which defines the shape of the distribution, right? Similarly, here N and P will define the shape of distribution.
Shape of the distribution.
In case of Bernoulli, it is P, right? Only one probability success.
Only one, yeah.
Similarly, I think if you go for any maybe geometric,
Poisson is also lambda.
Geometric is P, right? So only one parameter, if you define properly, it will show the shape, right? So here in this binomial, N and P will define the shape of the distribution. Okay. So yeah,
Sir,
maybe
I have a question. Yes, sir, I have a question, but it is not from anywhere. It's I came across this question. So shall I like tell it? I got an answer, but I'm not able to justify it. So the question says that we have a pack of playing cards, and it had only 51 cards. Like one was lost.
Sorry. Okay.
So
sorry. Yep.
yeah,
Just,
sir.
again. Yeah. You have
So
pack of 52 cards.
Yeah, 52. One is lost.
Okay.
If first 13 cards were examined and all were red, then find probability that missing card is black.
Okay, these are 13 are red, but
Yeah,
red can be
red.
But red can be 26, right?
Yeah.
So out of 52, 13 has already examined. So how many
So
cards we have
51 out of 51 because one is lost.
Okay, fine.
Yeah, 51. One, out of
But
51,
I don't think so. We have
13
to
are
think
red.
about 51, right? Because we
Sir,
have to check whether that card is black, right? The lost card
no,
is black.
sir, we have to, lost card is black. So first the lost is done, then only the 13 cards are taken. So what happened is a pack of playing card was found to contain 51 cards. If the first 13 cards which were examined were red, then find the probability that missing card is black. So this is so sir, what I did, I just wrote 26C1 upon 38C1. First of all, this came to my mind to do this.
Don't do it. Go by step. Don't jump into the answer, right? So I don't think that will help you anywhere. So let's say it's 51, 13. You are, let's say, how many cards you are remained with? 38, right?
38, yeah.
And in that 38, we'll have how many cards? We'll have some red cards and we'll have some
black cards.
But those, so out of this remaining cards, there is a possibility that there can be 13 red cards and how many
25 black cards because one is lost. If we consider black to be lost, or 12 red cards and 26 black cards.
So these two are the possibilities, right?
Yeah. Yes.
Okay, give me a minute. I'll just see if this.
Yes, sir.
I got the solution of mock. Maybe I'll ask them to upload. Check what there's. Okay, so yeah, so you just wanted to find the black card is lost.
Yeah, black card is lost. If the first
But I
13
think, see,
found
I
were
think
red.
what you are missing is you're just already considered that one card is lost, right?
Yes, sir.
So I don't think this will help, right? Because you are already saying that one black card is lost.
No,
See,
sir, but we don't know
no,
about
no.
whether it's
No.
black.
See, the problem is,
Yes.
yeah, that's what I'm saying. We don't know, right, which card is lost. Why you're, because in this case, right? See, if you just add these numbers, already one card is missing, right?
Yes.
You're not. So I'm not about just
Sir, that is
specified that.
from
Sir, what
52.
I
Then second case 51, 12 by 51. Another one, if it is not lost, 13 by 51.
This is what this is.
So what I considered was that there were three conditions, like even as missing card is black, another condition that missing card is red, and now we have to make a conditional probability that if probability that all first 13 cards were red when a black card is missing, and then probability that all 13 cards were red when a red card is missing. So we'll get then we'll apply Bayes theorem and we'll get answer like that. So I thought it was that, and the answer according to that solution was coming. But another method that I applied, the answer was not coming. So I just wanted to confirm that. So yeah.
No. See, I think this creating the events, I'm not like. See, so what is the probability that?
Sir, can't we directly have 26 C1 upon 38 C, but we don't know about black card. Yes, sir.
Okay.
Yes, sir. Sir, can't we have 26 C1 upon 38 C1 for the black card lost? Like now that 13 cards are red, so we can remove them. So we have total 38 cards. And out of that, we have to determine if a black card is lost. So can't we have 26 C1 upon 38 C1, like probability of a black card missing out of 38 cards? Hello, sir.
Yes, just
Yes, sir. So 26 C1 upon 39 C1, like that. I
Why?
just thought
Why?
about.
See, just
Sir,
don't.
what will happen is
What is the
that
approach? What is the approach?
yeah, 13 cards we have seen are red. So suppose we have 52 cards and 13 are red. So we remove them, we have 39 cards. We are including all the cards for for assuming all cards. So now when we have removed 13 red cards, we are left with 39, complete 39. And now we have removed now what is the probability that the card is missing card is black? So we have 26 out of 39 as black cards. So 26 C1 upon 39 C1, that is 26 upon 39 should be the probability of a black card missing when 13 are red.
That is what
This
came
is
to my mind. I'm not sure.
Yes, sir.
So what is your answer? The final answer is what?
26 upon 39. That is, I think, 2 upon 3.
26 upon 39, which
39.
is because.
Sir, we have 52 cards if we consider all the cards. So 52 misses, first 13 are red. So we remove 13. So now we are left with 39 cards. Out of these 39 cards, one is lost. So 26 are black. So one of the black is lost. The probability that the black will be lost is 26 upon 39. Because 13 are already red. So 52 may say we remove 13. And then 26 upon 39 will be the probability of a black card lost when the first 13
No,
are
okay.
red card.
Why 26? No, first 13 I understand. This 39 I number I understand. What is 26?
Yeah, 26 because we are taking all the cards. We have assumed first we have assumed all the cards we have taken. Now what we'll do, 13 cards, we knew that they are red. So now that the probability that one card is lost will be out of the remaining 26 black cards out of 39. So 26 upon 39 is the probability that one black card is lost when the first 13 cards saw is red. So that's what, because we are not considering black cards. No, 13 are the red cards. So red cards are removed. Now all we are left out of the remaining all 39 cards is black 26. So if the black is lost, so it will be only a single card. So 26 upon 39, 2 upon 3. So yeah, so this is what I was thinking.
Yeah.
So is this approach like considerable?
No,
I think this.
yeah, no, this is correct, because see, when I have total of 52 cards, right? What I'll do is, it's already
Remove
13
13 as
removed.
red. Yeah.
I know
So we
that,
have
right?
13.
Now,
Yeah.
out of 39 card, if I want to choose one, there are 39 C1 ways. But out
Yeah.
of this,
We have to choose only a black card
black,
that
right?
is missing. Like what?
But
Yeah.
But if the black is missing, that means any one of the black card we have to
Is
choose.
missing. Yeah.
Which is 26 C1 ways.
C1. Yeah.
And it's not there. So that one
Yeah.
card is there in the
Not
pack
there.
of the
Yeah.
cards. In the
Yeah.
39.
So
I think
yeah,
that
out of, I
yeah.
think this will be fine, sir.
Mm.
Yeah. So sir, should I go with this solution? This
Yes,
solution
yes.
will be right, huh? Oh.
Yeah, that will be correct. Yes.
Yeah, sir. Another one was that there is a set of 3 numbers chosen from set 1 to 2n plus 1. Like there is a set of numbers from 1 to 2n plus 1, natural numbers 1, 2, 3, 4 till 2n plus 1. We have chosen any 3 numbers from it. Any 3 numbers. What is the probability that they are in AP?
Okay. So what is arithmetic progression?
So arithmetic progression is like there is a first term and each term has a difference, a subsequent difference between them.
So it is A plus D, A
Yeah,
plus
A plus 2D, A plus and D, या ऐसे करके देखो.
No, we have only 3 now. Now we have to choose the 3 numbers. Right?
So,
I
sir,
think
but
this,
they are not consecutive. They can be like if we take 1 and 5 and 7 and 1 and like that also is in AP. I also thought A comma A plus D, A comma 2D, but then I realized that they have not said consecutive. They have said like we can have any. So if we take like 1 comma
okay,
19
no.
comma 23.
But this
Yes.
is not consecutive number, right? A plus D.
Yeah, they are not but when we say D, they will be consecutive, no? Because the difference will be D. So
No, that is fine. These are the consecutive numbers in
3
a
numbers.
progression. In the progression.
Yeah.
But I do not. I can choose from this, right? So
Yeah, we
see,
can.
the difference can be. Let's say if the difference is 1.
Yes.
So these numbers will be 1, 2, and 3.
3.
Right? But the difference is 2. Then it can be 1, 3, and 5.
5.
Right? If the difference is 3, it will be 1, 5, and
5 comma
8.
1 comma 4 comma 1 comma 4 comma 7.
7. Right?
Yeah.
So as you change the difference, but anyway these are in
AP.
Right? These are in AP. They are not consecutive, right? Consecutive natural. They are not consecutive natural numbers. Even though the initial lot we have to choose is like this, right? So
Yeah.
Okay. So what? But again, the choice will depend on what is A also, right?
Yeah. First of all, like I thought that we can't take these, but we can. So we like and 2n plus 1 are the numbers which we have. So first number we can take like 2n plus 1. Like we have 2n plus 1 chances that we can take a number, and then I blacked out, and so I asked.
Okay, but see again, this is like very complex question to solve. But yeah, maybe we can try it. But okay, can we have that question? Because I don't think that question is anywhere related to your exam. If you wanted to
Yeah.
do it after the exam, or
After
maybe you can
definitely,
postpone
sir.
it, right? Because I don't think
Definitely.
yeah, because wasting time on this question, because this is
Bilkul,
not
sir,
a very
definitely.
straightforward question.
Yes,
right?
I was also thinking that whether this will be like fine because it might not be related, but then I thought, okay, I'll ask and then we'll see.
Because here your choices will be how to find A first, right? then
Yes.
you have to choose the value of d, and accordingly you have to choose the numbers. That will be right. The denominator
Yes,
is very
sir.
straightforward. It is 2n plus 1 c3. You can choose any three numbers out of this, but the
Yeah, that
numerator
is fine.
you have two conditions.
Yeah, we have to
First
follow.
condition is A, and the second condition
And
is
then
what
we have
is
to
D,
follow D.
right? And how many choices will be there to
Yeah,
find D
definitely.
also? Because I do not know. I cannot have D as 2n plus 1. I
Definitely,
should
yeah,
have
sir. It is.
D as 2n minus maybe 2. No, no. First of all, it should be half of this, right? Because if I have 1 as A, the middle is, let's say D is n, then n will, this is n plus 1, and I think then it can have
There is a relation. A plus B divided by A plus C divided by 2 should be B.
so yeah, so D should be, let's say, n, right? Okay. Then it will be 1, and then it is n plus 1, and how much it is then? 2n plus 2, but this is not again possible, right?
Sir,
Choice
we
of
why N? Okay, D we can take as N. No, N. Okay, okay, okay.
n can be half of this, right? At least half, right? Or at max
Yes,
half, right?
sir. So N minus 1, can we take D as N
Okay,
minus 1?
fine.
D,
We can
no,
see, you have to first
yeah, we
choose the
have
maximum
to.
position, and accordingly you have to select
We
the
can,
numbers.
but we can say anything. Like we can have any possible
So,
value of D.
for D, I
Yeah.
think it should be NC1, right? One of the n's. So one of the values from. Okay, maybe okay. I think we'll discuss it maybe.
Yeah, this will
So
be
have you
okay, sir.
explained the 11 and 12?
Can you please explain geometric progression PDF first problem?
Yeah, I will do that. So it won't take much time maybe, because I think we have seen one problem already on geometric distribution. We'll just extend it to that.
In that
Okay.
PDF first problem, I got it.
I will do it. Yes. Okay.
Second and
But
third, stood
but
first
these
one.
questions are fine, right? All these other questions from this mock.
Sir, I have a doubt, sir.
Sir, any 11 questions, sir?
Third question, sir. Third question.
Third.
11.
Okay, third and 11. Okay, then I think I have solved almost every question, right?
So we have
Okay.
solved 12, 1.
13.
Hey, 12 and 13.
12 have you
13,
done?
sir.
13, I don't think so. I need to explain. Same question is there in grade assignment. Okay.
Yes.
12
Sir,
maybe I
could you once
Sir, 11
explain
and 12,
13,
sir.
sir?
Because the
okay.
conditional probability happened. 11, 12.
12.
Okay. 11. Okay, I'll go for 11. Okay, maybe. So if you wanted me to solve, then just I'll solve it directly. Okay. If you wanted me to solve all the questions, I'll solve it like very in the faster mode then. Okay. So I'll go with the question number
12,
maybe
sir.
11,
11.
12.
Yes, sir.
Yeah. 10th is no one is having problem, right?
Sir,
10th is very big.
10th, can you tell once?
Okay, maybe I have to solve all the questions. Okay, 10 is x will take, see, it's simple one. Okay, so just make it as a PMF 0, 1, 2, right? What are the probabilities associated with this is 1 by 3, 1 by 6, and 1 by 2. Is 1 by 3, 1 by 6, and 1 by 2. Or I can write this PMF as like this, right? So it is 1 by 3 when x equal to 0, 1 by 6 when x equals to 1, and 1 by 2 when x equals to 2. What is CDF? CDF of x. It is probability that x is less than equal to x, right? This is what CDF of x, right? Or it is written as f of x. Correct?
Yes.
So here we have asked for f of 1. Okay. So f of 1 is what? Probability that x is less than or equal to 1. Right? What does that mean? It is less than or equal to 1 or less than 1?
Less than
or equal to 1.
Less than 1.
P of x is equal to 0 plus P of x is equal to 1.
Okay, who has asked me the question? This question. What's your name?
Me, sir.
Yeah. Okay. What is CDF of x? Or what is f of x?
Sir, P of x less than equal to 1.
Less than or equal to 1 or less than 1?
Less than equal to 1, sir.
So you are sure about it now?
Yes, sir.
Or you? Okay. So why? Okay. This is my PMF, right? This is my PMF of x given. So how to find probability that x is less than or equal to 1?
Sir, is it 1 upon 3 plus 1 by 6?
What is no? Okay, that is okay. But okay, that how can I write like this? What is x is less than equal to 1? What are the events
Okay,
x is less than?
P of x equal to 0 plus P of x equals to 1.
Right?
Yes, sir.
Right. So what is probability that x equals to 0?
1 upon 3 plus 1 upon 6.
6. So which is nothing but what? So 2 by 6 plus 1 by 6, right? If I wanted to make denominator same, so it is 3 by 6, which is nothing but 1 by 2, right? F of 1 is equals to 1 by 2, which is nothing but 0.5.
Yes, sir.
Okay.
Yes.
Okay. So can you tell me what is f of 2 here?
1, sir.
F of 2 is equals to 1. What is f of 0?
1 upon 3.
1 upon 3. Okay. Understand?
Yes.
Okay. So that's.
Sir, can you just show answer of your last question because answer disappeared from our
Which answer?
last 16 ones, sir. Just only answer.
16?
0.
Can you tell me the question? Are you have the answers at your
No, sir. Answer disappeared, sir.
no answers are there?
No, sir.
Okay. Miss, you didn't have the answers itself, huh? From the starting itself. Is it like that?
No, just try to submit the
Submit the assignment, you will get the answers, right? That's what I'm thinking about.
It has become practice assignment now.
Yeah, it has become practice assignment now. Yeah. So yeah, question number 11. Let x become x is an exponential distribution, exponential lambda. And find the value of z such that this should be equal to right. Okay. What is the value of lambda? But it's not there. Okay, I don't think so. Okay. Okay. So x is exponentially distributed with parameter lambda, right? What is the CDF? What is the PDF? And okay, what is the CDF of x now? F of x is equals to
1 minus e to the power minus
1 minus e power minus.
sorry, PDF 1 minus e to the power
minus lambda.
Okay, what is
Yes.
given? Probability that x equal to 100.
Given it was greater than
Greater than 100.
given it was greater than 50.
Greater than equal to.
It's the same thing. It's the same thing.
It's exponential distribution, so it's a continuous distribution, right? So when the continuous distribution is there, it does not matter much. Okay. Okay. Okay, it does not matter that inequality sign. That is the thing, right? Okay, fine, sure. So and we have to find
X is greater than Z.
Greater than Z. Okay, this is the okay. Now, how to write the so what is probability that A given B? It is probability of
A intersection B upon probability B.
Right. Okay. What? How to write this? Probability that x greater than
Is
100.
greater than 100 upon probability of intersection probability of
But the intersection will be x greater than 100.
100
yeah,
on.
yeah, because since x is greater than 50, and so yeah, so let's say this is the number line, this 50 and this 100, right? So whatever things are greater than 100, that and what is greater than 50? All these things, right? So intersection of
Intersection
two
is
will
greater
be
than 100.
greater than 100. This is the part, right? So this is
Yes.
how. So this is nothing but what probability that x is greater than 100 divided by probability that x is greater than or equal to 50, right? Okay, I'm just solving the left part of it. Then we'll solve the right side of it. Okay. Okay. Probability that x is greater than 100 is what? 1 minus probability that x is less than or equal to 100. Right. Similarly, probability that x is greater than 50 is what? 1 minus probability that x is less than or equal to 50, which is nothing but what?
e to the power minus lambda.
E to the power minus lambda
into 100.
100.
So that means 100 lambda.
Lambda.
100 lambda, right?
Correct.
Divided by e to the power minus
50 lambda.
50 lambda, right? Okay. Similarly, what is probability that x is greater than z? This is 1 minus probability that x is less than z, which is nothing but what? E to the power minus lambda
That's it.
z. So can I have this equal to e to the power minus lambda z? This is fine?
Yes, sir.
Okay. What is this ratio?
E power minus 50 lambda.
Minus 50 lambda.
So
Minus 50
lambda is 50.
Lambda is 50.
I mean Z is 50.
Z is 50, yeah.
Right? Because if this equality has to hold true, then my lambda, my z should be equal to
50.
I think 50 is the correct answer, right?
The 12th one as well.
Sorry?
12th question, yes, sir.
According to the survey, the time taken by teenagers to finish a box of donuts is uniformly distributed between 1 to 6 minutes. So what is the PDF of this? This is uniformly distribution, right? Continuous uniform distribution. What is its PDF?
1 by b minus a. 6 minus 1.
Minus a divided by b minus a.
No, that is CDF, no? B minus A. PDF is 1 upon 5.
1 by b minus a.
So 1 upon 5. Right? B is 6, A is 1. So it is 1 upon 5, right?
Yes, sir.
Correct. No?
Yeah.
Yes. Okay. Now, a cafe in New Delhi used this data for its advertisement that challenges teenagers to finish a box of donuts within 100 seconds. So, 6 minutes means what is the maximum time in seconds? It's 120 seconds, right?
Yes, sir.
Okay. And okay, so first of all, let's draw this. So B here is what? 120 seconds. A is
So 720 seconds. So 6 so 360 seconds.
Sorry. Yeah, sorry. 60 seconds in 1 minute, right? So 6 minutes is 360 seconds. What is 1 minute? A is 60 seconds, right? So
yes, sir.
Let's say if I draw the graph here, uniform distribution, this is x. So it will confine between which 60 to 360, right? And since it is uniform, what is the probability?
1 by 300.
Yes, sir.
Right? Correct?
Yes.
Okay. And this is uniform, right? And what I have to find out is if a cafe in New Delhi used this data for advertisement that challenges teenagers to finish a box of donuts within 100 seconds. So if they are finishing the box of donuts in less than 100 seconds, they will win a prize. A teenager Ajay accepted the challenge, and we have to find out that he will finish the box of donuts within 4 minutes, given that he has already lost the challenge. So when any person will lose the challenge,
when time is
more
more than
than
100
Greater than
seconds.
100.
so if they go beyond this, they will lose the challenge. what is what probability we have to find out here?
Below 4 minutes, that is 240
So 4
seconds.
minutes is how much?
240 seconds.
240 seconds. So let's say this is the yes 240. So we have to find that he has done. We have to find probability that
100 x is greater than 100.
No, x is less than
Less than
240. Given that
yeah, x is greater
x
than
is
100.
greater than 100. This is the probability I have to find. This is conditional
Yes.
probability, right?
Yes.
Fine.
Sir.
So this is
Yes,
nothing
sir.
but probability that x is less than 240 intersection x is greater than 100 divided
100
by probability that x is
greater than 100.
correct. Okay. So x is less than 240 and x is less than 100 means how much?
Sir, probability of x less than 240 minus
140.
probability of x less than
140
100.
by 300.
So this is 140 divided by 300. Everybody understand this point? Why this probability is like this?
Yes, sir.
So it is nothing but actually 240 minus 100 divided by this 300, right?
Right.
Or else I can see like this. Maybe
240 minus 60 by 100 and 100 minus 60 by 100.
yeah, that is also fine. So yeah, anyway, so
Correct.
yeah, if you can say like that also,
Yes, sir. Yes, sir. Okay,
it is
got
with the
it.
yeah, these are the basic rules, right? Like 240
X minus A, yeah.
divided by 100 or minus
360
100
minus
minus
60, yeah, upon
like
300.
so anything is same, right? So
Yeah, okay, got it, sir.
so we'll go directly to this step where I can say it is 240 minus 100 because we are interested in this area, right?
Yes.
When I do the conditional thing, if it is not conditional, then I have to include all this area, right? But it is conditional, so this is the area. So it is 240 minus 100 and divided by, since each of this has to multiply with the probability, right? So
Yeah,
it is to be
definitely 1
multiplied with
upon
1 by
300.
300. So that's why it is 140 by
140
300.
upon 300, yeah.
And divided greater than 100 is which area? This pink color area, everything. So it is 360 minus 100. Again, you can
1 minus 40
maybe,
by
sorry, 1 minus 40. Where is 40?
That's what going to be, sir. 1 minus 40 by 300. That is 60 by 300. For the bottom part, for the denominator.
yes, sir, for the denominator.
Denominator is what?
1 minus 40 by 300.
That is going to be 260 by 300, sir.
Yes, sir, 260 by 300.
Okay, so yeah, okay. Why you said 1 minus 40? That's what I'm just okay. That is correct only. But how you directly approach that number?
For x less than 100, it is 100 minus 60 by 300. And for greater, it will be 1
You said
minus.
okay. You did it like this: 1 minus
Yes,
probability
sir.
that x is less than 100. Okay.
Yes,
And
sir.
then
Yes.
1 minus okay.
40
What is
upon
this?
300. 40 upon 300.
Okay, fine. So yeah, anyway, you can just with the graph also you can see it like this directly. It's 360 minus 100, right? Fine. Anyway, it's fine.
Got
So it is 160 by 300. So 300 get
260 by
10.
260 by 300. Yeah, 7 by 13. Got it, sir.
So just a small doubt. It's related to this conditional probability thing. Anavji posting the question in the chat box. You just a quick. I don't need the full explanation. I would just need the answer to this. You can just directly tell me the answer. That will be fine.
The amount of time that a particular machine can run before its battery wears out is exponentially distributed. That one, right?
Yeah. That's this way.
Within average of 100. So lambda is what? How much?
1 by 100.
1 by 100. So this is a 0.01. Okay. The
Correct.
owner of factory needs to run that machine more than 50 hours to complete a deal with the company. If the owner has some noises coming from where it is coming. Okay. So if the owner has already used the machine for more than 40 hours to complete the previous orders, then what is the probability that he will able to? I think this is a question I have seen somewhere. this is maybe graded or I don't know.
Yes, this is a previous question, and somebody actually asked this in the Discord forum. I actually responded to that, but the answer doesn't lie in the range. I even asked Farhad sir this question.
Okay.
Yeah.
Okay. Okay. So the owner has to run the machine more than 50 hours to complete the deal. If the owner has already used the machine for more than 40 hours to complete the previous orders, then what is the probability that? So given that he has already completed 40 hours, what is the probability that he will be able to complete the deal
That
without
is
having to?
greater than 50. Given greater than 40, what is probability of greater than 50?
That is the question, right?
Yeah.
No. That is not a question. I think needs to run a machine more than 50 hours. Okay. If the owner has already used a machine for more than 40 hours to complete the previous orders, then what is about that? Will be able to complete the deal without having to replace. Okay, is it a simple question or is it a complicated question? I'm just,
So what I thought was, I'll tell you that this is probability x greater than 50 given probability x greater than 40. So to cut the calculation short, I would just say that it's memoryless. So x greater than 10 would be the answer for this. So that comes out to be 0.904. But actually the range is 0.606. So that we only can calculate if we take x greater than 50.
Sir, what it was actually discussed in one of the
I think
previous
I
sessions.
have discussed
So,
somewhere.
sir, it was told that probability x greater than 50, condition probability x greater than 40 will be probability greater x greater than 50, because probability x greater than 40 will be considered as 1 because it is written that it has already it has already been used for more than
Just a
40.
second.
So
That solution, Farhad sir gave that solution.
yeah, I
Test.
also got 0.6 only, that only,
No.
but it was
We
told that.
0.6
discussed
is
this
incorrect.
yesterday, sir.
Yeah, just a second. 0.6 is incorrect. I have actually consulted with
My
Farhad sir.
I also
The
got that
answer,
answer, but
yeah.
Okay.
it was P's
Anyway,
x. Yeah.
Okay, so my conclusion over this question is maybe the statement of the question is not very clear about. Okay,
Yes, it's
because
kind
if
of
you wanted
ambiguous.
to have 0.6, well, it's not given that is it used already or not. Somewhat ambiguous, but okay. Anyway,
Sir, if it's greater than 40, then there are chances that it can lie between 50 and 40 as well. So for that, we should divide it
greater
by.
than going for greater than 10, I think that is not a correct answer for this question, which I feel, because how can you go greater than, because you are
No,
doing the
sir,
membrane
not greater
property,
than
but it's
10.
not.
Not greater.
No,
Mine
somebody has
was
done
that
that.
P.
No.
Oh.
I was just talking about the memoryless property
But
of this.
here memoryless may not, you know,
So it
it
says
will
that
not serve.
given it has worked for more than 40 hours, that owner has used it for more than 40 hours, what is the probability he will be able to complete the company A order, right? So the condition for company A order is that it has to be, the machine has to run more than 50 hours to complete that. But given it has run for more than 40 hours, what is the probability it will run for more than 50 hours?
So it will be probability x greater than 50, condition x greater than 40.
Yeah, that
So we'll get like intersection. So it will be probability x greater than 50 upon
The
probability
answer
x
comes
greater
out to
than
be
40.
0.904
E
if
power
you go
minus
to
1,
that.
which is
We'll
0.9.
get e power minus 0.1 also.
Correct. That's what my answer is, but that's incorrect.
Yeah, I know that's incorrect because it was told that px is greater than 40 to be 1.
So if we say that probability x greater than 50, given probability x greater than 40 is probability x greater than 50, then similarly the question in the mock test is also the same.
Yeah,
You can
that's what
also
I was
say
confused because then we have to consider the second condition has already happened. So it
correct.
always will be 1 then.
Correct.
Yeah, I got confused. Yeah, I was also confused in that thing.
This should be the case, right?
Yes, sir.
What
Yes, sir.
you are talking about. So if
Yes,
x is
sir.
greater than 50 and if it is going greater than 50, but actually this is not the sense of that question. What I feel is because uh, see this condition when it comes, right, able to complete the deal with company A without having to replace the machine battery.
Without replacing the machine battery.
Okay, fine. So okay, what will be the case then? X is greater than
Sir,
40.
it shall be px greater than 50 because 40, if it's 40, then it will have to be
Correct.
50, and
So
upon px greater than 40.
If it is greater than 40, yeah, it should be no, but again, when it's already been there for.
If it is to replace the battery.
One minute. X greater than 50 and intersection of x is, so if I do this, so let's say it is 40, this is 50, right? So when I say x greater than 50, this is the area, and x 40, this will be this area, so it will be x. Okay, I think it should be provided that x is greater than 50 divided by provided that
X greater than 40. Yes, sir, that's what I also
yeah,
did.
that should be the correct answer maybe. So it will be so it will be e to the power minus 50 by 100
50 upon 100 upon e to
and e
the
to the
power
power minus
minus
40 by
40
100.
upon 100.
So it is e
E
to the
to the
power
power minus 10 upon 100.
yeah, so it will be e to the power minus
0.1. That is
0.1
0.9.
minus 4, yeah.
0.9.
How much it is?
0.904.
0.904. I think. I don't. 0.9.
Yeah, I think that should be the answer. Okay.
But the answer
Sir,
given in the
It's okay. It's
rate.
okay. That is okay. No issues.
Sir,
Yeah, let's move.
sir, I have a doubt from a previous year question only. Sir, it says it's a very small source. Sir, it says Priyanka selects two numbers from set of
Okay, one
n
minute.
natural numbers.
First of all, have
Yeah.
you finished this question? 12th one? Finished, right?
Yes, sir.
Okay. Okay. Go ahead there.
Yeah. Sir,
any other question left in this paper? Which I
Sir,
have to
yes, sir.
Which one?
The penalty question, sir. Can you discuss that once?
The third question also, sir.
Then what are the questions remaining?
The 16th one once. Can you show, sir? Yes, sir.
Okay,
this
maybe.
one.
Okay, I'll discuss everything. Okay. Anyway,
Yes,
it's
sir.
only two questions I'll be left with then. Okay, the variance of a binomial random variable x is plotted against varying values of p and with n constant. It is observed that maximum value of variance is 40. What is the value of n? Is plotted against varying values of p and n. It is observed that maximum values. Okay. So what is the variance of x?
N
In case
into
of
P
binary,
into
40.
1
Yeah,
minus
and
P.
into p, where I'm saying that what
variance
is
is
constant?
maximum.
N
N
is
is
constant.
constant.
N is constant, right? So n into
Yes.
p into q is again n into p into
1
minus
minus
p.
P.
So this is constant, right? So only thing variable is this is the variable, right? Right. And if I wanted to find the maximum of variance, how to find it? We'll
If we
do
differentiate it, it should be 0.
Differentiation should
with
be
respect
0.
to what? With respect to p.
P.
Right.
dv by dp. Yeah.
So it will be d by dp of n into p into 1 minus p, and it should be equated to 0, right? Okay, so let's do this. N
N into 1 minus 2P into N.
I'll do it my way. Okay, so you know this, then what is the problem here? This, can you tell me this? Huh?
Sir, I didn't know it actually. I mean,
No,
I
I
didn't
think she
get
has
the
asked.
point.
I think she has asked me. Who asked me the question then?
I asked for the question.
Okay.
I mean, I didn't think about this differentiation.
Right.
Okay,
Okay.
so
Fine.
now I understand. Now I understand.
Okay. Fine. No issues. So this is 1 minus 2p because n is constant, so it can become. So it can. So 0 by constant will be again equal to 0. which is 2p equal to 1. So p equals to 0.5. That should be the answer, right?
So variance is maximum when probability is 0.5, right?
Yes.
Can we approach the other way? Like variance is maximum when
Yes,
is
but that is correct
0.5.
only. No, that is a property actually.
Yeah.
In case of
So just
binomial.
oh yeah, okay. I just okay.
Okay. Let's move to the question number 13, right?
13, yes.
Okay, so the company has predicted this is the distribution given for me. X is what? Profit, right? Profit, and minus will indicate negative profit or a loss. Okay, so but the company cannot return all the profits to itself since it has a share of 15%. The amount that the company retains is given by y equals to 0.85x. So y is what? Is a function of a random variable, right? Y is a function of x. What is the approximate standard deviation of y? Okay, so how to, let's say y is my random variable, how to find the standard deviation of x, or how to find the variance of y?
Sir, expectation of x square minus expectation of y square minus expectation of y whole square.
Right, this is the formula. And what is standard deviation of y?
Under root variance of y.
Right, so I need to find first of all variance of y. For that I need to find what? Expectation of y square, and I have to find expectation of
y.
y. What is y here? Y is 0.85 times x, right?
Yes.
Okay, what will be expectation of y then? It will be
0.85 expectation of x.
Yeah. What is expectation of y square?
Expectation of 0.85 x whole square. 0.85 square x square, yeah.
So it is square x square, right? Okay.
Yes.
I know now x, I have values of x as minus 0.5 and whatever values are given, probability of x equals to x, and the respective probabilities are given. How to find expectation of x? Minus 0.5 into or maybe I
Sir,
can write the
multiply
formula.
each value of x with their respective probabilities and add them.
And what is expectation of x square?
Multiplying each x square with their respective probabilities and adding them.
So if I find expectation of x, I will replace here. I will get expectation of y. If I find these values, expectation of x square, I will get the values of expectation of y square by plugging in the values here. And after that, I will go here. I will plug in these values, expectation of y square and expectation of y to the whole square. I'll get variance of y, and I'll find a standard deviation of y. Understand? So I'm not going to solve this because it will take a lot of time to. These are all the calculations, and I think we have the one question related to this, right? So
Sir,
Excuse me,
I
sir.
have question.
We just need to find the variance of x. So can
that
you
is
show
also
the
fine.
yeah?
That is
So
also
that
fine.
way from the equation just come like that. I think that is the better way.
Same thing, na? Same. See,
Y
the
is
thing
equal
is,
to yeah.
so let's say y is equal to
Equal to
0.85x.
0.5.
Okay.
So variance of y is equal to
No, leave about the variance of y later on. Okay, maybe that. Okay, variance of y is what? 0.85 square.
0.85 whole square x.
yeah.
Variance of x square.
Variance of
So, and variance of x is what? Expectation of x
Expectation of
square
x
minus x
square
square.
minus expectation of x whole
So
square.
it's very easy to
Same thing.
yeah.
Same thing. Again, you have to find expectation of x square from the distribution.
Yeah.
Expectation of x from the distribution. And okay, any approach is fine because all the equations are coming from the same point.
So just one clarification. So even if I try to substitute x and then make a random variable y and then do it manually like the way how we do for x, still would that be the same?
Yes,
Yeah, that's
same.
Okay.
Same.
Okay,
Both the things which I have shown here is they are the correct approaches to solve this question.
I think
Okay.
maybe I would have done some mistake. Okay, sir. Yeah, thank you.
Okay, fine.
Sir, I have 2 questions from PYQ. Can I ask them?
1 minute, 1 minute, 1 minute. First of all, we'll finish. Previous year questions, I think Bharat and Rajkishore are solved.
Sir,
Right?
they are different. Like they are not from those papers that were discussed.
First of
So,
all, I'll finish this
yeah.
paper, and after
Yes.
that, I will have only 15 minutes. Okay. Anyway, this is the extended too much, and again you have exam.
Will you explain geometric distribution today?
Yes, yes.
Okay,
So
okay.
yeah,
I'm
last
waiting
15
for
minutes. Yeah, I
okay.
will take the questions until 15 minutes. After
Please, sir.
that,
So
no question will be taken, and only the geometric distribution I'll
thank you,
discuss.
sir.
Okay, so I think one more question I have remained with from this is 16th,
Last
right?
question, sir.
Last question, sir.
Okay, the average number of penalties charged by a police in a day for not following the traffic rules is 5. Okay, so lambda is given as 5 because this is a Poisson distribution. So what are the average things are there?
Expectation is equal to lambda, so that's why it's 5.
Okay, find a probability that less than 4 penalties will be charged in a day. Okay, so x is what? The Poisson distribution with lambda. So x Poisson with lambda is how much?
5.
5. Okay, what is the distribution of or what is the now I have to what do I have to find is provided
CDF
that
of 4.
x is less than
CDF
4,
of
right?
4. Yeah, CDF of 4.
Less than 4, which is f of 4, right? So what is the CDF of Poisson?
Probability x
3
equals to
power
0 plus
minus
probability x equals to 1, 2, 3.
politics.
No, but like tell me the formula, right? It's
There's
not
no
problem.
formula for CDF for Poisson.
Okay, fine. Okay, yeah. But, so in terms of summation, it is there, but okay.
Yeah.
So okay, tell me what is how to solve this then?
Just x equals to 0 plus x equals to 1.
Yeah, I have to do quality x equal to 0. X equal to 0 of it. E raised to minus lambda, lambda raised to x by x factorial.
No, just tell me until what point I should go.
Just
Yeah,
3,
till
3, sir.
4.
3, sir.
3. Till 3.
This is important.
Yeah.
Then only the plugin of the values, right?
Yes, sir.
What is it? So what are the so what is PDF? So probability of not PDF, it's PMF, right? Poisson is a discrete random variable. So probability that x equals to 0 is what? It's I think it's lambda e to the power minus lambda x upon x factorial. This is what? Probability that x equals to x in case of Poisson distribution, right? Which is 5 e to the power minus 0 divided by
No, that's
Sir, is
yes,
lambda power
that is
x?
yeah, e raised to minus lambda, lambda raised to x by x factorial. E raised to minus lambda, lambda raised to x into lambda raised to x. Lambda raised to x by x factorial. Yeah. E raised to minus lambda into lambda raised to x by x factorial.
Fine. So lambda to the power x is 0, right? E to the power minus 5 divided by 1 plus lambda to the power 1 is lambda e to the power minus 5 divided by 1, right? Plus e to the power minus 5 square divided by 2 factorial plus 5 cube e to the power minus 5 upon 3 factorial. That should be the answer, right? So I think 5 to the e to the power minus 5 you can take out common.
Take out and
1 plus 5 plus 5 square plus 5 cube upon 2 factorial upon 3 factorial, right? That I you can see like, what are the values. Fine. Okay.
Yes, sir. Sir, previous year question, shall I? Sir, there are only 4 questions and 2 are very small, so I hope they end up soon. I'll try. Sir,
So you'll
first
ask me all
question.
4 questions, huh?
Yes, sir. It will be very helpful. Okay, so first question, it's a bit lengthy, but it's very important. Sir, in a particular game, the player needs to throw a dart onto a circular board whose radius is 5 units. The points allotted to the player are based on where the dart lands. Let R be the distance at which the dart lands from the center of the board. then the points allotted are 10 minus greatest integer function of r, where greatest integer function of r means the integer part of r. Example, 5.5 is equals to 5, 5.9 is equals to 5, and 5.1 is equals to 5. Let x be defined as sum of all the scores obtained after 5 dart throws. What is the value of expectation of x?
So tell me, you tell me, what is your approach?
Sir, I was so going for like, because it can be any value, because first throw it can be values like, because it is 5 units radius, so it can be from 0 to 5. But it can be because 10 minus r, so it can be 0 to 5. Then
Okay,
also it can.
no. See,
So
just
like 5 throws we'll have to add, and it will be lengthy. That's why I
see,
couldn't.
don't see what is the problem. All of you face this. You'll just directly land up to the answer. You'll just thinking about all the 5 throws, right? Just think about only one throw first of all. Okay, what is the
Yeah.
radius of that entire dart?
5 units.
5 units or 10 units?
5
5
units.
right?
We
Okay.
have to find 10 minus greatest integer of r, where r is the value at which the dart is from center. So suppose r is 2.5, we have thrown at suppose 2.9. So the value of greatest integer of r is 2, and then the point that the person will guess is 10 minus 2, that is 8 points will be given to the person.
Okay.
So it is this. Yeah.
And what is the after 5 throws, how many? What is our goal?
Expectation. We have to access the number of scores
So
he has
that means
gained in 5.
what is the point, right? Expectation is leave about that. What is so what is the random variable you will define here?
So the
X will
random
be
variable
the point,
x is defined as sum of all scores obtained after 5 darts.
Yeah,
Like it is
points.
sum of all. 5.
Okay,
Sum
of 5 also is fine, but sum of 1, and because all these are independent darts, right? You can just take one only and you can multiply with 5, because these are independent and identically distributed throws. So you can just add. So consider first throw as x1, then x2, then x3, x4, and
x4,
x5.
x5. Yeah.
You just find the expectation of this and you just multiply with 5. This is the correct answer, right? So for first throw, what are the points one can gain? So he can.
Yeah.
Tell me. Yeah.
Yes, sir. Sir, it can first it will land on 0. Suppose it can the value of r can be
Is
0,
between,
1, 2, 3,
yeah,
4, 5. So values can be 10 marks, 9 marks, 8 marks, 7, 6, and 5.
So when this dart land between 0 and 1, it will be 1, right?
Yeah.
So the point will be 10 minus 1, which is, or
9.
no, 0. So it will
The
be
first will be
10 minus
0 because it can land exactly at the center as well. So when r is 0, 10 minus 0 is 0. 10 minus 0 is 10. So 10 and 9 and 8, 7, 6 and 5.
5 now won't be there, because
5.
you will have 5 when it is 5 point something, right? Or
So,
when
but
it
sir,
land
but
between
what,
5 and
sir,
see,
what
see.
is the condition that it
Okay.
lands exactly at the like brim 5 points, like 5 exact distance is 5?
So that means it will land on this edge.
Exactly, but it
I don't
can
think
land.
so. I don't think so that 5 will be there.
So
because
similarly, when we are thinking 10 as well, 10 is like at the very center, because if it will land at center and r is 0, then only it can get 10 points.
no.
Okay.
When r is
Yeah.
between 0 to 1, I will have 0, right? Correct?
Yeah.
Because 0.1 can be
Yeah.
considered 0.
0.1, yeah,
0.2 can
0.
be
It will
also,
be 0.
correct?
Yeah.
So this is not the case when I have exactly center. Right?
Okay.
This is what I feel. So I think the random variable take values between 10 to 6.
So sir, we will not consider 5.
No. Then
Okay.
what is the probability associated with that? So when this is 10,
Five throws are there. So 5.
5,
What is the
what I told you is
Yeah.
consider one throw.
Okay. First,
For one
Sorry.
throw, find the probability distribution for that, and then
Okay.
multiply with the 5. I think that is the
Okay. Yeah.
simpler approach which we can find. Right?
Yeah. That will
Okay.
be.
So for what is the probability for when I throw the dart? So at 0, between 0 to 1. So what will be the probability? I think it is
10,
area
1
between
upon
that, right?
10. 1 upon 10. Acha, हाँ,
No,
okay, it can go
no.
beyond.
Pi r square, right? So what is the area between 0 to 1?
Hmm.
This circle, right?
Oh, yeah.
What is that?
Pi r, because 0 to 1, that is, it
Pi
can be
r.
it can be from 0 to 1. R, like
Ah,
it R will be 1, R will be 0,
ah.
R will be 0 always. Yeah. Pi r square, R will be 0, so area will be 0.
No.
Sir,
This is the
because
area.
R can be but we are calculating probability. Yes, sir. So R can be from 0 to 1 any value.
So maximum will be r. Okay, what is the area of this circle, man? This, let's say this is a circle, right? This is having a radius of 1. What is the area
So
of
we'll
this circle?
integrate from 0 to 1, or like.
Arey, you know the formula of circular area, right? What is that? Pi
Yeah.
r square, no?
Yeah, pi r square. But
Pi r
R
square
is
is,
changing from 0 to 1. Like,
doesn't
so
matter.
how? Acha, okay.
See.
Yeah.
Okay. Integration of this is not equal to area or what? Okay. Can you tell me what is the basic thing? So okay,
No, sir, not.
I forgot about the things. Some of
Yeah.
you might not be from math background, right? So the thing is, what is integration? Integration is nothing but the area under the curve, right?
Yeah, area under the
Area
curve.
under any curve is nothing but the integration of uh, uh, a small thing, right? We are integrating.
Yeah, very small to like whatever is the
Right,
range. It is.
right.
Yeah, it is
So
that.
that is the
Yeah.
integration. So when I say the area of this circle,
Yeah.
this is nothing but the area of the circle from 0
0 to
to
1.
1.
Yeah.
So
Integration.
everything will
Yeah.
be so when I integrate between 0 to 1, that small
Hmm.
thing, right?
Yeah.
Which
It
you
becomes
have to
whole
find. It is becoming the which gives me the area. And
area of the whole circle. Yes,
but
sir.
I need not to integrate here because I know the
Okay.
area of circle directly with the formula
So,
which is pi r square.
but
So
sir,
this is
pi r square, but R's value is changing now from
r
0
is
to
1.
1.
R is 1.
Acha, R is 1. Okay, we are.
When I say r is 1, this is equal to same from 0 to 1. Whatever change is there.
Sir, how, sir? I didn't get this. R is 1 for 0 to 1.
Okay.
Sir, this kind of question will come, but it has come in previously. I was thinking that this kind of complicated question will be there.
See, because we are not asking this kind of questions since the integration is not covered. Previously, we used to ask questions, but the simple thing about this is integration is not needed here. Okay.
Acha.
Even though you
Yes,
are thinking about this is not the case. So here,
okay.
it is just
Yeah.
when I wanted to find the probability rate, I need to think about r equal to 1 here and divided by r equal to 5.
Okay.
See, okay, if I start the class with the integration, right, it will take a lot of time.
I understand that.
See, it is
That's why I
not
was
the
confused, sir, because why is this question, how
okay.
can this question be there?
No, these are the questions
Yes.
from probability actually. These are very standard questions of
Yeah,
probability.
these are good. This is a good question, but then it was in
okay.
statistics, so I was confused that
Now
this kind of
okay.
question.
Okay, wait.
Yeah.
If you speak a lot, it will take a lot
Yeah,
of time.
sorry,
Right?
sir. Sorry,
So
sir. Yeah.
it's generally it's pi r square. Okay,
Yes.
this is the area.
Yes, sir.
So I wanted
Yes,
to
sir.
find the area between 0 to 1, radius
Yes,
0 to
sir.
1. It is directly, I have to consider r equal to 1 and I have to find the area as pi r square, which is
yes, sir.
pi into 1, which is pi. Okay, divided
Yes,
by,
sir.
so if
This part, R is equals to 1. Like,
yeah,
why? Because when we'll consider
why
pi is
don't
equal.
ask now?
Acha.
Maybe once we'll finish the integration part, right? Maybe or
Oh.
maybe some other day when I'll have the time, I will just tell you. This pi r square is so it is the area when we integrate from 0 to 1. I'll directly get
Yeah.
this area
Okay. ठीक है,
because
directly pi into 1.
yeah. So integration, right? This is 2 pi r dr actually. 2 pi r and dr is the
dr. Yeah.
smallest thing. Okay.
Yeah.
And we are integrating 2 pi r dr from 0 to 1. Okay. This is 2 pi r square by 2.
2.
Okay. 2 will
Yeah,
get
2
cancelled.
will
This will
get
become pi
cancelled.
r square
Yeah, this is
between 0 to
standard
1.
for circle. Yeah.
So pi 1 square
Okay.
minus pi into
Minus.
0. So this
Okay,
is
we have
0.
applied this.
So
Okay.
I'm
Yeah.
just telling you this is pi r square.
Okay, got it. Yeah.
So even if you are not for introduced to this concepts, I'm not just I can't go to the integration, right? Because other students.
Definitely.
Okay.
Okay.
So this is the
Okay.
direct question. This is not like I'm just saying that
Okay.
why I'm taking
Yeah.
a one.
Can we move
No,
to
got
geometry?
it. We in simpler terms also we can say that pi r
Inspires me.
radius 1 is bigger circle, radius 0 is small circle. So difference between the area is pi r. Okay.
Yeah. Okay. And the denominator it will be 5 is 5 square.
Pi 5
Okay.
square.
So this 5 upon 25 pi, which is nothing but 1 upon 25.
1 upon 25. Yeah.
So this is 1 upon 25. Okay. Here it is 4
Okay.
upon 25. Why? Because
9.
9
sorry.
means
9 means we have radius still 2.
So I think no, it is 0, right? Because
No,
it is
radius is still, yeah.
so
For 9 means the r value is greater than 1. 1 से लेकर 2. It is lying between 1 to 2. Yeah.
Okay, fine.
Yeah,
1 by 2. So it is
4
1 to 2,
square
right? So 4 by
minus 1
25.
square.
4 by
4
25.
2 square minus, yeah, 4 sir, 3 I think, because pi r
No.
square minus नहीं
R
करेंगे
equals to 2
sir.
here, na? R equals to 2, right?
From 1 to
Okay.
2.
Again, I have to reduce it. Okay,
Subtract 4
into
pi minus
3.
1 pi.
So this is 3 by
3
2.
pi. Okay.
Okay. Similarly, you can find out the values. Okay.
Okay.
And then you can find the expectation of x as 10 into 1 by 25 plus 9 into 3 by
3 by
25
25.
like this, and the entire will be multiplied by 5 because 5 rows are there. So
Okay,
whatever
so
the
it will
expression
be
is
like,
there, that will be the answer. Okay.
okay, 5 multiplied. Okay,
See,
sir.
this is kind of
yeah.
very complicated question. Mostly won't be asked in the question paper, so I'm just not giving so lot of time to that.
Answer, it was of 6, I think 6 marks or 4 marks. So that was I got
The
right.
next
And
question.
Can we
yeah,
move
the
to
next question is from the same previous year. So let a random variable defined as number of heads after tossing an unbiased coin 100 times. What is the probability that value of random variable is less than expected value of random variable? That is P of x less than E of x. Sir, a coin is random variable is defined as number of heads after 100 tosses of unbiased coin. So what will be the value of Px less than E of x?
Sorry. Yeah, just tell me once again.
Sir,
give me the first.
unbiased coin. Sir, unbiased coin is tossed 100 times. X, that is the random variable, is number of heads in 100 tosses. What is the value of probability of x less than E of x?
Okay. What is the expectation of x there?
Sir, nothing is given. Sir, options were the correct answer is 1 minus 100 C50. Yeah. Sir, there are multiple select option. It's like that. So the answer was there only one, which was like in numerator we had 1 minus 100 C50. I'll tell you the answer. The total answer was 1 minus
Answer
100.
is okay. No.
Yeah.
That's okay.
Yeah.
So let's say one unbiased coin is tossed. Unbiased means, let's say it is the probability of success as P.
0.5 into 0.5. Yeah.
No, not 0. It's fair coin.
Fair coin, na, unbiased coin. So probability of head is 0.5 and tail is
0.5 into 0.5, and
yeah,
it is thrown for 100 times, right?
100 times, yes, sir.
Okay. So what is the expectation of x?
Sir,
N into
number
p. This is
of
a binomial.
heads can.
It's a binomial problem, right?
50, sir. N
So
into
it is
P.
n into p, right?
Okay.
This
Yeah,
is a binomial
binomial.
problem, right? So it is
Yeah.
100 into 0.5, which is 50. Now,
Okay, yeah,
now they
100.
have asked that probability that x is less than 50 because x
X
is
is less
50
than
less than
50. Yeah.
greater than or
X
less
is
than
less than. X is less
50.
than 50. Yeah.
This is the question. Probability that x
Question.
is
Yeah.
less than 50 is probability that f of 50, CDF of
50. Yeah.
So in
CDF.
that
Yeah.
case, so just think about it, right? So it is What will be the values then?
Less than 50 is like
It's a
it can
binomial
be 0
distribution.
to 49. 0 to 49 it can have X can have values.
So
Yeah,
just
0 to
see the options. What
sir,
are
options
the
are there. Sir, option there is like the correct option is half minus 100 C 50 0.5 to the power 100 upon 2. Like this was a vacant because I know we can add like that is correct, but the correct answer is given as half minus 100 C 50 0.5 to the power 100 upon 2. So this was vague condition. Well, I don't know how
So
did we get this.
I have done a similar question.
The answer, yeah.
Probability x equals to 0 till probability x equals to 49 is actually equal to probability x equals to 51 till x equals to 50. So if you consider that a and a, it's 2a plus b, that is b is probability x equals to 50. And the sum of
Yes, got
2a
it.
plus b equals to 1, and after that is just manipulation.
How did we get 2a?
2a is probability x equals to 0 till probability x equals to 49 is equal to probability x equals to 51 till probability x equals to 100.
100. Okay.
Yeah.
So, but it is 100 C 50. Like 2a if it's given as
See, if you take probability x equals to 0 till probability x equals to 49 as a.
Yeah, I got it.
Probability x equals to 51 till
51
probability
to 100. Yeah, it is same.
is
It is same.
b.
It
It
is
is
same.
b.
Yeah.
And
Yeah.
probability x equals to 50 as c. So a
C,
plus b
okay.
plus c equals to 1.
1, definitely.
Yeah. So you 2a plus
Okay.
b equals to 1, and you just have to find out the a part.
What is
Okay.
probability of 50 actually? See, probability of 50 is what?
You
Now,
can
see,
consider
this is probability of 1 to 49 is similar
1 to
as a
49
1
as
to
a.
100,
A.
right?
Yeah.
Okay, so
And
these are
51 to
same.
100
So
is
it is
a.
2a.
Yeah.
What is
They
probability
are
of
same.
50?
Okay.
It is 100
It is
C50,
C50 0.5 to the power 100.
right? Equal to?
Yeah. 1. Okay.
So you can just manipulate.
Okay. Got it. I was getting confused.
And I think this is also not needed maybe if you consider half also directly. Half minus, because I think probability that x equal to 0 after probability of x equals to 50
49.
also, this becomes
Yeah, it will be the same answer. Sir, 49, I think. X is
49 is
0 to 49. It will not consider 50 because it is less than 50.
I
No?
think in
So
the option it was mentioned that
it was
100
mentioned, but
C50
in
into
this
0.5
question,
raised to power 101, I think.
No, it was. I think it was repeated twice or thrice in papers. So in one paper, it might be, but in the paper that I looked, it was 100. So next question, it is. There is what can be said about correlation coefficient R of x and y when y is equals to minus x square minus 3x minus 5.
y is equal to minus
X square minus 3x minus 5 when x takes value of first 20 positive integers.
So
What can
what
be
will be
said
the
about
graph?
R?
Okay, what will
Yeah,
be
sir.
the graph?
Sir,
So
it's
this is
it's going to be
non-linear. It is
negatively.
Not linear, but
yeah,
but
negatively.
but it is what x is
Curved.
0, then it will be minus 5, right? And so
Sir, it's
as
non-linear, right?
Negative
It's
parabola.
non-linear is fine, but so try to find it. It's
But
a
sir, R,
quadratic equation, right?
when we define R, we say that it determines linear association, and here it is
Yeah.
going non-linear.
No,
So
it's
how?
okay now. It's okay now. So what is your conclusion then?
Sir, my confusion. No, sir.
No, what is
I
your
didn't get the
conclusion?
answer.
What is the answer?
Sir, answer is -1. Like R belongs to 0, -1 to 0. Like it is belongs between -1 and 0. This is like because it's negative. So I thought that, and the answer also that, but I didn't get the like how to approach it because.
Okay.
Yeah.
Okay. So can you tell me the simple thing? Just Leo about
Yes,
this.
sir.
Can you tell me what is the correlation coefficient of this line? Let's say all these points are on these lines. What is the correlation
Sir,
coefficient?
it will be 1.
1. Okay.
It will be 1, yeah.
Now consider these points. But what will be the correlation coefficient of these red points? Or what is the range, like from where to where
0
it
to
can
1,
be?
sir. 0 to 1.
Yeah,
Can it be?
because it's
Okay.
positive. Because because it's going in a same direction, so it will be.
Okay. So you
Okay, yeah.
see, is it linear or okay? Are these points linear or they are having some non-linear?
They are non-linear.
But still, you are having that correlation coefficient. So ideally, you should not be able to define, right? But it's not like that, right?
Okay. So we can define R for like no quadratic or these conditions as well.
Right. So the quadratic will look like, maybe these points can be like this, right? -5, 1.
Okay, yeah.
So let's say 1 for 1. If I replace it 1 minus 3, 1 minus
So
5,
it
9. Right? So it
minus
will
9,
be
yeah.
-9. So
Very
maybe
down, yeah. Yeah, it will be both negative.
So some kind of things are there, but the correlation coefficient is 0 when these points are lying like this.
Lying in a straight negative line.
No. R equal to 0.
Acha, R equals to 0. Yeah, R equals to 0
When
when
this
it is
correlation is
very
not there.
scattered and because there is no association.
But here you can, if you try to fit the line, these points will be somewhere, but the coefficient is not 0. Coefficient is between 0 to 1.
Sir, in this cases, will we have to use the concept of best fit, like line of best fit and good fit?
Not required. Currently not required for the syllabus. Okay. But one thing you have to understand is R is not equal to 0, or there is a correlation.
There is a
right?
correlation. Yes. So I actually got confused in linear and quadratic. Okay. Yeah. And sir, the question says Priyanka selects two numbers from a set of natural numbers till n. Find probability that they are consecutive. Like 1 to n, and she chooses two numbers. What is the probability that they are consecutive?
Okay.
So
and how
yes,
many
sir.
two numbers she has chosen, right?
Two numbers, yeah.
Okay. In how many ways one can choose?
So NC2.
No. Okay, that is okay. Two numbers.
Yeah.
Okay, choosing two numbers is NC2. That is fine.
Yeah.
How many ways we can select the consecutive two numbers? Either I can have 1, 2, 2, 3.
Yeah. 2, 3.
3, 4, 4, 5, like that. N minus 1 into n. Right. These are the only things, right?
Yeah.
So how many are there? N minus 1.
N minus 1 pairs. So n minus 1. Yeah.
So I have to choose one,
N
right?
minus, we have to choose one pair out of
one pair out of this, right?
Yeah.
So can I have this?
N minus 1 upon NC2.
Can you check if this answer
Sir,
is
I
correct?
came across this answer, but there is one thing. Sir, shouldn't it be into 2 on the numerator?
What?
Sir, into 2, like n minus 1 C1 into 2. Sir, what I thought that she's choosing two numbers. So what if she chooses 2 and 1? They are also consecutive. Like if she chooses 1 and 2, but there is chance that she might pick 1 comma 2 or 2 comma 1. So
But here it's not arrangement, right? It's a selection. So here order does not matter, right?
okay. Okay, acha. Okay, so means 1 comma 2 is same, like she
Same
can
as 2,
pick
1,
that.
right?
Okay, and sir, she in uppercase if you are taking pairs, so in lower it is like in NC2, so it will be fine, right? And
Because
minus 1 upon
I'm choosing two numbers from anywhere, right? Any I'm not confined to some condition, right? So that is
Yes.
right.
Yes. Yeah.
Similarly,
Okay,
for
yeah.
triplet also, I think one of the ones that maybe just before finishing, I need to finish that, right? The geometric one.
Geometric, yes.
Or a doubt related to that. geometric distribution.
Ah.
It's in practice assignment 9. Last question, sir.
Oh, practice assignment week 9.
Practice assignment week 9. Last question, sir.
Practice assignment there are.
Hello.
I'm just opening it.
Sure, sir.
Okay. Okay. So before that, maybe I'll take what is geometric distribution. Right? So you know this formula, right? What is geometric distribution actually? So if I have n trials, right? N trials, or maybe I'll read the definition from here itself. So geometric distribution this is discrete. Geometric distribution gives a probability that the first occurrences of success requires in a k independent trials. So for example, let's say uh, you are defining the success as head. Okay, when you are tossing a coin, you are defining success as head, and the probability of getting head is p, suppose. Okay, and if I say my fifth toss, in the fifth toss I will get a head. So what is the probability that I'll in the fifth toss I'll get a head? That means I didn't get a head in first toss, right? I didn't get a head in second toss. I didn't get a head in third toss. I didn't get a fourth toss. Right.
I
So
got
in
into
that
it,
case, So in that case, suppose 1, 2, 3, 4, and 5. In the fifth toss, I'm saying I'm getting head. That means I got tail in the first toss, tail in the second toss, tail in the third toss, tail in the fourth toss. Since I'm defining head as a success, what is the probability that I got tail in the first toss? 1 minus p. Since these are independent, again it is 1 minus p. I can multiply the probabilities, right?
Yes, sir.
1 minus p, and in the fifth toss it is p. So what is the probability? P into 1 minus p to the power 4. So what is this? This is the probability that x equals to 5. What does that mean? I'll get a success in the
fifth try.
Okay, this is the meaning of it, right? So this is called a geometric distribution. Okay, so for, let's say I wanted to find probability that x equal to n. What is it? What is the probability? What does it mean, probability that x equal to n?
So, getting success in the nth tokens.
First success. Okay, first
First
success.
success in
This
the
is important. This is
nth token.
important thing. Getting
Yeah.
first success in the
nth token.
nth try. So what is the probability related to this?
Probability into p into 1 minus p
1 minus
raised to power n minus
n
1.
minus 1.
Right. This is my geometric distribution. So this is mentioned it. There are two types of model, I think, associated for this geometric distribution. One is, I think I have already mentioned, but okay, these are some assumptions which are okay. This is independent trials are there. Then you have only, for each trial you have only two outcomes, which is a success and a failure, because this is also a class of Bernoulli only, right?
Yes, sir.
Because you are repeating the same trials with the two outcomes only. And here the only thing is we are going to find the probability for the first success in the kth trial, right? So that is there. Okay, this is what this is a CDF f of k, which is probability that x is less than or equal to k, and this is given as 1 minus 1 minus p to the power k. You can easily find it out. Okay, this is okay. Okay, is there any problem? The formula.
So the formula for x greater than k is wrong. It should be 1
Yeah.
minus p to the power k.
So it's okay. You can just correct it. Okay, I think this is wrong because probability that x is greater than k should be 1 minus probability that x is less than or equal to k. So it cannot be 1 minus p to the power k. Okay, this is the problem. Okay, this is the wrong formula given. So it should be 1 minus p to the power k. Okay. Find expected value is 1 upon p. You can easily find
Is
it
that
out.
1 minus p to the power k is the formula?
For x greater than k.
Okay, so here why not for x is greater than k, right? It
Oh,
shouldn't
yeah.
be this thing, because if less than k is 1 minus p to the power k, then
Yeah.
it should be automatically 1 minus p to the power k. So this is wrong. Okay, this is wrong. This should be 1 minus p to the power k. But see, we are not going to ask that difficult question, but just I'm just you just have the formula. You can easily find out how, or you may be uh, remember this formula 1 upon p and 1 minus p upon p square. But if you are not able to remember, it's very easy to find the expectation of x. How to find the expectation of x? It is, since it's a discrete variable, x into, right?
Yes, sir.
Yeah.
So what is x here? So okay, what will be the distribution of this? What is the PMF of geometric distribution?
No idea, sir.
So
Same thing.
1 minus p raised to power n minus 1 into p.
Oh, yeah. Yeah.
This is PMF, right?
Oh, okay, okay.
Huh? Is
Yes,
PMF.
sir.
What is the range of geometric distribution? It will start from 1 to infinity.
Infinity.
Why 1? I'll get success in the first trial, right?
Yes, sir.
Or I can get a success in second trial, or in the third, in the fourth, like that. I can get infinity. So my range of x here is
0 to infinity.
no, not 0, 1. 0, no.
Oh,
I cannot get a success in the 0 trial, right?
oh yeah, sorry, yeah.
For getting a first success, I should need at least 1 trial. So it is from 1 to infinity, right? So how to find this expectation? 1 into probability that x equal to 1, right? Plus
Yes, sir.
2 into probability that x equals to 2, plus 3 into probability that x equal to 3, like that, right?
Yes.
Okay. So it is 1. What is probability that x equal to 1?
P.
P. 2 into what is probability that x equal to 2?
1 minus p into p.
2 into, you are understanding, right, all of
Yes,
you?
sir.
Why x equals to 2 is p into
1
1
minus
minus
p.
p, plus 3 into p
1
into 1
minus p
minus
raised to
p
power 2.
into 1 minus p, which is
Raised to
square,
power
right?
2. Yes.
Into p. Okay.
Right? Okay. Similarly, it is 4 into p.
1 minus raised
That means
to power 3.
in three trials, I didn't get the success. In the fourth trial, I got the success, right? And
Yes, sir.
similarly up to infinity. So here, which is my r here?
1 minus p.
1 minus p.
1 minus
2,
p is no.
2p.
So I
2 into 1 minus p.
No.
Okay, I can okay, maybe I can take p common. Okay, inside it will become 1 plus 2 1 minus p plus 3 into okay, so I think it's difficult right here. Okay, so I think it will go 4 into 1 minus p cube and like that, right? Okay, so I thought it is a simple thing to show this 1 upon p how it comes, but okay.
If that 1, 2, 3 was not there, we can do that.
That was
Yeah.
simple one actually. Okay, okay. So there is a proof for this, but I think okay again it will take a lot of time. I think, right? Okay. So maybe we can just directly remember. That's a better thing, right? Currently, maybe if you want, I will just share that proof also. It's not a problem. Okay. If
So it's
my x is geometric, okay. If it is geometric, what is expectation of x? 1 upon p, and what is variance of x? It is 1 minus p upon p square, right?
p square.
But don't worry about this. We are not going to anyway. So this is difficult formula. Maybe you just remember this one.
Okay.
Expectation of x should be 1 by p. What is PMF of x? a PM of a geometric distribution, it should be
1 minus p raised to power n minus 1
okay,
P
into
into
p.
1 minus P.
or maybe 1 minus p to the power n
n
minus
minus
1
1 into p.
into p when n trials are there.
Yes, sir.
Yeah.
Okay, so nth trial will be
Success.
n trial will be my first success.
Yes, sir.
Okay. Okay. So maybe we can take a question from here. Which question do you want me to solve?
First question, sir. First question, I have confusion.
Okay. Suppose that the number of runs scored of a delivery is uniform in this, independent of what happens in other deliveries. A batsman needs to bat till he hits a six. What is the probability that he needs fewer than six deliveries to do so? So what is success here?
1 by 1 by
Getting a
6.
six.
1 by 6, sir.
Yeah.
No,
Yeah.
that means getting a
Getting a
six.
6.
So getting a six is, if it is a success, so what is the probability that I'll get a
1 by 6.
success? Is 1 by 6. What is the probability that I'll get failure? That means I will
5 by
hit
6.
1, 2,
5
3,
by 6.
4, and 5, right?
Yeah.
So that will be 5 by 6, right? Because everything is uniform, right? So
Yes,
it is
sir.
5 by 6, right?
Yes, sir.
Now the question is, uh, what is probability that he uh, he needs fewer than 6 deliveries to do so? So what does that mean?
Uh, Fewer than 6 means if x equals to 5 and less than 5.
So that means
Limited to 5.
he will get a 6, or he'll hit a 6 in the first delivery, or he'll hit a 6 in the second delivery, or he'll hit a 6 in the third, fourth, and
5.
fifth, right?
In
So
this way, it is okay, but if it is the other, I mean, cumulative.
so I can actually use the formula which is given there, or I can use the
This one we can
original.
find out, but
Yeah.
the other formula, I think it is wrong. The in the solution.
Okay, we'll see. So what is probability that x equal to 1?
Sir,
It's p.
Uh,
It's p.
1 by,
p.
yeah, 1 by
So this
6.
is 1 by 6 plus x equal
5
to 2
into
is
6 5 into 6 into
5
1
by
by 6.
6 into 1 by 6.
5 by 6 square into 1 by 6 plus 5 by 6 raised to power 3 into 1 by 6 plus 5 by 6 raised to power 4 into 1 by 6
okay.
plus 5 by 6. Yeah.
Done, right?
Yeah, done.
So 1 by 6 common. So remaining is 5 by 6 plus 5 square by 36 square. Can somebody, maybe if I'll do
1 plus.
Huh?
1 plus 5 by 6.
1 plus 5 by 6. Sir.
1 plus
5 by 6.
is it the answer?
1 by
Oh,
6 is
1 plus is
common.
there.
Yeah, 1 plus in the
1 plus
beginning.
is it cannot. Oh, okay.
5 by 6 is common. Yeah, and 1 by 6 is
Sorry, I thought the proverb you were giving me the answer. I thought.
no.
Yes, 5 cube by 6 cube plus 5 to the power 4 divided by 6 to the power 4, right? Divided by 6. So it's 0.598 something, right? So this is the correct answer, right?
Yeah.
So this is the formula you can remember directly. This is the CDF formula. F of k equal to probability that x is less than. This is the formula. I can use directly this formula, or
So in the solution, they are given the other formula, probability of x less than or equal to 5. It should be like 1 minus p of p, right? It is
That's wrong, sir. That should be 1 minus p to the power k.
1 minus p to the power. So p is 1 by 6 here. But it is 5 by 6 here.
In that,
That's why.
we were calculating x greater than k. Here we are calculating x
oh no,
less
no.
than k.
She is saying that it should 1 minus p to the power k, right?
Yeah.
So see, this is okay. 1 minus 1.
So it should be 1 by 6 instead of 5 by 6.
Yeah. I thought it is. I just confused whether it is my mistake or.
No, there
Okay,
are
okay,
mistakes in
here,
this PDF.
okay, here is a mistake. Okay, fine. Sure. So this is not a correct formula actually. Okay. So
It is, the answer is correct, sir. 0.59.
no,
Just the value should be 1 minus 1 by 6.
okay, maybe see what you can do is, okay, I think I haven't seen this one. Okay, I haven't checked this document actually. Okay, fine. But you can use you can maybe search the formula which is less than. So I think see 1 minus, this is the correct answer, right? Let me check once. 1 by 6.
If we use 1/6 also, it won't be correct.
This is the formula. If 1 minus 1 minus b to the power p, right? No.
If we replace 5 by 6 with 1 by 6, the answer comes out to be 0.598.
When you give the 5 by 6, I mean 1 minus 5 by 6 or the other one.
No. If we replace 5 by 6 with 1 by 6.
No.
Correct answer getting, right?
Yeah.
Okay. Oh, okay.
What you done?
Just replace the probability to actual probability. So here we are taking probability of failure instead of probability of success.
Okay.
So 5 by 6 is incorrect. Here it should be 1 by 6, not
1
5
by
by
6.
6.
Yeah, 1 minus 1 by 6. That's what I
1 minus 1 by 6,
1
right?
by 6.
Yes.
Still
Failure is 5 by 6, right? Probability of failure is 5 by 6. So 1 minus probability of failure raised to power 5. That's what the formula is. 1 minus probability of failure raised to power n. So we have
Still it is
already calculated probability of failure 5 by 6. We can just
okay.
replace this whole term with 5 by 6. That can work.
Right. Okay. So yeah.
The idea is that is
Just
we
make
are
the,
1 minus. Yeah.
So I think the more proper solution to this is maybe you can check on the internet what is the CDF of this. Okay, it is available, and if you don't
I just
remember
I
this,
have already checked it, sir.
Sir, there is another way. I think if we are just 1 minus. We are subtracting probability of not getting no success. We are just that way. I'm thinking in that way.
okay.
Yeah.
So okay, fine.
Probability of no
So
success. We are just subtracting.
no, but
Probability.
I think the best way to find currently is just go by this way. Okay, the simpler because we didn't provide you any lectures and notes for this.
So we can also do one thing that we probability x equals to 6 we can find out and just take the complement of that.
That is the same thing actually it is there.
Yeah.
So CDF of x is nothing but that only, right? Probability of finding it's a complement of this is.
Oh, can we get that probability of x equal to 6? Then 1 minus that answer
No, that's
will
it.
get the.
Yeah, this is the actually CDF that formula is CDF
Okay,
formula.
okay. Oh,
They
okay,
have
okay.
done the mistake in writing that.
Oh.
I will correct that one. Okay, but yeah, anyway, you don't have much time to do that. It's better that I have seen because I haven't seen that in much closer.
Sir,
I didn't give the much closer look to this. Yeah.
a related question to this geometric distribution, sir. I asked you that practice assignment 9 last question. It's
Okay.
actually related to this. So
Okay, I'll take this one and then we'll stop.
Sure. Last question, sir. Last question. Ramesh Suresh. So I will tell you, sir. I get the solution that's given in the practice assignment, but I have done it through geometric distribution. So maybe you can just read the question first, then I'll explain how I did it.
Okay, the book Ramesh and Suresh are using to play book cricket contains 10 pages, 1 to 10, with the right side pages containing even and assume there is an equal probability opening for each page. Okay, the probability mass function is this. Okay, Ramesh and Suresh scores respectively. Okay, okay. What is the probability that Ramesh will be not out at the end of his chances? So when he will get out is, I think it is given here, right?
Yes, sir. Yes, sir. So he will
Initial
get
score
out
is
if the last digit of the
if you get 0, you
yeah,
are out.
0 that is 10.
Okay.
If you get 10, you'll get out.
Out. Yeah, only when you have 10, you get out,
Correct.
right?
So it says that they will consider the marks. Consider the score on the right side. That is the even numbers they will consider. Second line, sir. Kind of conditions. You need to randomly open a book page. The
So
last digit of
only 2, 4, 6, 8, and 10.
correct.
These are the
So
only
yes,
possibilities where I can
correct.
take the scores. So
So
either I will score 2 or 4 or 6 or 8 or 10. 10 means
correct.
out.
Correct. So what I did was chances of him getting out is 1 by 5. That is, he gets a 10. Chances of not getting out is 4 by 5. And here it says that he'll have maximum 5 chances. And the question says that what is the probability that Ramesh will not be out at the end of his chances? So I thought, why not 4 by 5 raised to power 5, that he didn't get at any of the chances.
Correct.
So, but that's not the answer, sir. It's 4 raised to power 5 divided by 1365.
So what is 5 to the power 5?
5 to the power 5,
3125.
5 to the power 5 is 3125.
What if no, but I think you have the group your initial score. I think you haven't considered that, right? The Suresh is also playing, right?
No, so see, in this question, sir, it says that okay, if you get out at your first chance, then you will not get the 4 chances. So if Ramesh is playing, that he'll get all the 5 chances. He will play all the 5 chances, right? So till then, there is no chance of Suresh
Okay.
playing
So
it in between.
only Ramesh has to play, right? So
Correct.
let's say in the first chance he didn't get out, it's 4 by 5. Right? Second chance it is 4 by 5. Third is 4 by 5. Fourth is 4 by 5, right? So similarly, it is should be.
So in the solution, sir, what they have actually done is they have taken into account that he got out at the first try, second try, third try, fourth try, fifth try, and he didn't get out at all. And this is the total cases, and this is the denominator part, and the numerator part is he did not get out at any of the. So they have taken favorable cases out of
That I
12.
understand,
Yeah.
but so that means we are missing some cases here, right?
So I didn't get that part, that which cases am I missing? Because here the question is only that what is the probability that Ramesh will not be out at the end of his chances? He has 5 chances, and probability doesn't change, because it's not that okay, I am saying that once he get one page, next time he will not get that page. Probability remains constant, because every time he can get a 10 or the other numbers. So it would be 4 by 5 and 1 by 5 for each try. So that part I didn't understand, that which is the cases that I'm missing.
I'll just see, because you do it in both ways, right? You should have the same answer, right?
Correct.
That you agree, right?
Yes, sir.
So that is there. So let's say I'm doing in another way around is total number of ways. How many total number of ways are there to play
I
this
think it
game
was
is?
1365 something.
Why 1365?
No, no, that total. Okay, you mean what are the total number of chances he'll get to play? That is 5.
Yeah, 5 chances are there. 1, 2, 3, 4, 5
Correct.
chances are there. Each of the chance will have uh, 5 like each time he can have like
5
5
outcomes. 5 outcomes.
yeah, so 5 to the power 5 is total of 3, 1, 2, 5, right? And 1, 0, 2, 4. Okay. What is the correct answer here?
4 raised to power 5 divided by 1365, sir.
Okay, maybe I'll just check. Okay, what we are missing here is, yeah, I understand. So let's say you what you are taking count is if he this, right, 4 by 5, 4 by 5, 4 by 5. Okay, but what we are missing here is, let's say you said this is the probability that he's not out at
first chance.
But what is this probability?
Second chance he is
Not out
not
second,
out.
right? But it's not like that, right? It's 4 by 5 plus 1 by 5 into 4 by 5, right? He is out in, okay, but it's not the case, right?
Sir, that
But
won't
I
be
think
the case, right?
But it should be like this, right? But no.
No, he see. If I have 5 chances and if someone asks me, okay, you were not out at the after 5 chances, so that means I didn't get out at the first chance, second chance, third chance, fourth chance, and fifth chance.
Correct. I should add this, okay.
I have actually done this question multiple times. So back then,
No, I think
when we
okay.
didn't know
Yeah, I
distributions.
understand. See, this is 4 to the power 5 divided by 5 to the power 5 you are taking, right? Because you are considering that each time, like there are 5 options, right? I can have 1, 2, 3, 4, 5, like 2, 4, 6, 8, and 10, right?
Correct.
That we are counting. But here you see the total number of ways his chances could end in some of each cases is why the total chances are total of 1365. Yeah. The denominator, when we are taking that 4 by 5 as probability, right? In the first case, we are counting like that means we are taking the all 3125 chances, but I think some of the chances are missing here, and why that we have to check, right? The probability is calculated ways in which chances can be not out. Let us out in the first chance is one way, out in the second chance is when we are saying that 4 by 5, right, that means we are considering some more conditions which should not be there, right? I'm not able to understand why it's not there, because the solution which is given here, right, this also looks correct.
Both
Because
both solutions looks correct. That's why I wasn't able to understand that. Okay, what are the cases that I'm actually missing?
No, that is missing, because when I say 5 to the power 5, right, that comes out to be 3125.
Correct.
Which are more than like a lot more than 1365. So that should be 3125 minus 1365, right? the correct one, like where we have to, but I think that is not the case here. Okay, but right now I'm not able to see. Yeah.
Sir, but if we'll take like 5 chances and first one only, then we are like including the chance that 0 will be there. And if we are including 0, then next will like won't be there. So I think for the first case, we have to consider that it shouldn't be like include. That's why they have like added it in the end. Or total chances can be first it is out, second it is out, third it is out. So that's why it is added. Because if we'll take like five, like 4/5, 4/5, 4/5, that means there is a chance that in the first one you are out. So then the rest values won't be required. So
when we
on
do
the top,
that,
on the numerator, it can be 4 to the power 5, but I think denominator, that's why we have added.
if we are taking 4 to the power 4 by 5 raised to power 5, that means I didn't get out at any of the chances I played. That doesn't mean that I approach this question through geometric
No, for
distribution.
denominator, I think that's why it's added and not taken into 5, because I interpret
Okay,
it
okay,
that way.
okay, okay. No issue, no issue. Okay, leave out this thing.
Yeah.
Maybe you can post it on the Discourse, right? Once I'll get the answer, because I see it's like waste of time for a lot of you.
Sure, sir. Sure.
Because
Sure.
tomorrow you have anyway exam.
Yes, sir. Yes, sir.
This is the
Yes, sir. Yes,
only one
sir.
question, right?
Yes, sir. Yes,
Maybe we
Yeah.
can discuss it some other time. Yeah.
Sir. Sir,
Still
if
you
you
have
have
the
time,
doubt.
I just have one question. Just last one question. It's last, sir. I actually was searching for it,
Okay,
and
okay,
that's why, sir,
okay,
it's
fast,
last, very
fast.
last.
Yeah,
It's
because
sir,
I have to go
it's
for
in.
the
Yes,
dinner
I
actually.
understand. Sorry, sir.
Yeah.
It's last, sir. It is in mock for quiz 2, question number 10.
Mock
for quiz 2. It was in the like mock for quiz 2.
Sir,
It was
it's that ball question, sir. That company
no,
manufactures.
sir. It's not ball. It's that 3 free books one. Nitya has access to 3 free books
So
on a
that
website with
Python and machine learning
yeah,
question.
Python and machine
I
learning.
think that I have already discussed, right?
Yes, sir.
Last time itself, the quiz 2.
Okay.
Huh? If you can just
yes, sir.
It's already I have discussed. Okay. See,
Okay, it had
what
been
I feel
discussed.
is, yeah, okay.
Yeah.
Currently, I can tell you that won't be there. So don't. If you
Oh.
are not able to understand currently, just leave that. And if you
Oh.
wanted to do, just go back to that quiz, like mock quiz, right?
Mock
Last
for
time.
quiz 2. Yeah.
Yeah, that session I
Okay,
have
okay.
already discussed that one.
Okay. So I'll go after the exam to revise if
Yeah. So whatever
Thanks a
doubts
lot.
are there, just fine. Because
Yeah, definitely.
there is this kind of question. Maybe you can ask it like little bit earlier. Okay. At the end,
Yeah.
it shouldn't be right. So
Yeah, I was actually looking for it and I forgot where it was, so that's why I got confused. Yeah, definitely, sir. Thanks.
Okay, fine. All the best to all of you.
Thanks a lot, sir. Thanks a lot.
Thank you, sir. Thank you very much.
Thank you, sir. Have a good night, sir.
Good.